So the answer to that question is yes, it will now be recorded. We just figured
Okay,
out
thank
how to do
you.
everything. Thank you. Any other questions on logistics and setup before we turn it over to Brett? And hearing none, Brett, you got to come up here.
I did not produce slides because I've given this talk so many times. I could probably do it blindfolded.
Click and it'll move to one that just says. There we go.
Okay. So this village and this work that we're doing is really important when we think about the holistic view of cybersecurity. We've known since the early 90s that what we've been doing for security really hasn't been working. And so we've tried to figure out lots of different solutions, lots of bolt-on technologies to enable a more cohesive, cybersecurity environment. And luckily, Rich Struess at DHS started this concept for cyber threat intelligence sharing. And he tells this wonderful story that he went to a meeting where he wasn't invited and started proposing this idea. And out of that came this sticks in taxi work. And then eventually that work progressed and we, moved it to Oasis and I was, a tiny bit involved in that work for a little while. And then we realized that there's this thing that needs to happen beyond just being told about threat intelligence. They're told that there's a threat actor or there's a campaign. And we started to realize that there was a bunch of pieces missing that needed to fulfill this puzzle and to make the rest of this thing work. And so one of the first initiatives that got started was our course of action work. A few of us met at Cisco headquarters. We had this 2-day discussion with people from Phantom and Cisco and myself and a bunch of others. And out of that work came CACAO, or what we call the Collaborative Course of Action Operations for Cybersecurity. And that work is basically done now. The 2.0 version is just a few minor little technicalities with publication, but that work is basically done. And then there's these other things that have come along, the threat actor context pieces, the OpenC2 pieces, and all these things are coming together. And it's really going to enable cybersecurity to go to a different level. And so Jason Kierstead talks about this in the context of vendors need to stop competing on terminology and stop competing on information models and data models and start competing on something that they actually do. And so a lot of these standards are going to get put together and they're going to come into these cohesive ecosystems for products like what Vaughn's solution does, or some of these other products do, that will actually enable cyber defense to work at some sort of cyber relevant time. Because right now, nearly everything is manual. Most all of us have worked in the actual trenches or in a SOC before, spent many, many years doing this. And things are very, very painful and very, very slow. And vendors come along and they do this little thing and the other one does this thing, but they don't talk to each other. They don't communicate. They don't share. And there's, from an operational standpoint, it becomes really, really challenging to have a meaningful improvement in your cyber defense. And then if you do, you have no way of measuring it. And you have no way of knowing if you're actually making improvement. And so the things that we've been doing here through Oasis and through the Open Cybersecurity Alliance is trying to pull these pieces together and put in these various parts that are needed to make this cohesive ecosystem a reality. And today we're going to talk through a lot of the things, and people are going to show some demos, talk about how things can work together, where things are at in the ecosystem. I think Duncan's got a couple of demos you can do with his Raspberry Pi. We got some OpenC2 stuff. We have some CACAO playbook pieces, some TAC-TC things, and a bunch of others. And so the CACAO playbooks is really this kind of glue that will go from threat intelligence to, okay, so now what do you do about it? And then all of the other pieces, whether it's Kestrel or OpenC2 or all these things, can plug into CACAO and then make it so you can actually operationalize these things. The intent or the design is that over time, we'll be able to share, at least within ecosystems or trust groups, the ways in which we can operationalize cyber defense in more of a cyber relevant time. And so we've done a lot of work. One of the things that I put in for CACAO really early on, back when it was an IETF project, before it came to Oasis, is this ability that we could sign and countersign these playbooks. Because even sticks, we didn't have that capacity. And because if you're going to operationalize something and run something, you actually need to know that it's legit. So if Apple comes along and says, here is a solution for Fuzzy Panda, you need to be able to know that that's legit, because it might contain OpenC2 commands, it may contain Kestrel commands or other things like that. And so we've designed a solution for digitally signing JSON data. We had to write an IETF RFC for the canonicalization of JSON, and so that's done and published. And the actual digital signature work is actually being run through the ITU, so it'll get an X.dot number, so like X.500, X.509, things like that. But all of these are pieces and building blocks that are needed to enable a more cohesive cybersecurity defense posture. So today it's going to be a lot of fun. It'll be very interesting to see what people are doing and see the various demos that are presented. I know Vasilios from Norway will present some stuff. I know Vaughn has stuff. I know a bunch of other people have stuff. So that's my spiel of why I think this is important.
All righty.
Anybody have any questions?
All right. Well, thank you, Brett. Everybody online still hearing us okay?
Yes, sir.
Great. So that brought us perfectly back on schedule. I'll see what I can do to destroy that. Yep, no, you did. You could have eaten into mine. That was okay. So next we're going to talk about the use case that we set up to sort of put the context around all these demos. One of the other things that sort of grew out of the work that Brett talked about is we sort of all went off in our own little silos and did our own little thing on each of these individual projects, and discovered that by themselves, each one is valuable, but not all that valuable, that they're really valuable when you put them all together, and that the user community didn't really understand what we were talking about and how to put them all together and where the value was. So we tried to make up a totally fictitious use case. We have several of them, but the one that we're focusing on today, to sort of show to an end user, hey, why would you care about all this stuff? How would it help you? With that, I will dive into the infamous circle of all the projects. Some of these projects are more represented than others in the room. I believe there's someone from at least every one of these projects at least should be on the call. I notice there's a bunch of people not on the call that I did expect to be on the call. So I don't know if anyone's looking at any of the Slack channels or emails just to make sure there's not people screaming trying to get in, because we're even missing some presenters. So.
If I can comment on this, I think it's important for people to understand, because like a question that we often get is, why wasn't all of this work done inside of one group?
You're gonna have to come up and talk. They're not gonna hear you.
So one of the questions we often get is why all of this work wasn't done like within one working group or one technical committee or one project. And the reality is you need expertise from different groups, and you also need focus. And so all of these technologies are basically being designed to interwork with each other and to be, collaborative and to fit nicely together. There will be some minor differences, it's not like it's all being developed by one vendor, but I think the expertise that is needed to drive these is really, why these are kind of done in their kind of little bits and pieces. But what Duncan is doing here is trying to make all of this come together and show some real use cases of how you can use these technologies in a cohesive way to actually solve real problems. So, but that's why they're not all done in one working group or technical committee. It's because it just wouldn't make sense. So.
Thanks, Brett. And that does bring up another point for the people who haven't been involved in as long. For some of these, there's more than one way to skin a cat. One of the boxes that I just sort of lumped multiple ways to skin the cat into one area is called the software bill of materials. That area I've been very active in. And there's competing formats on how to do that. And the competition has actually been good. Both of them have gotten better as, one introduces a feature, the other one says, oh, I got to do that too, puts that feature in, puts another feature on top of it. The first one says, oh, I got to do that. So we're sort of all better off before that. And I liken it to, it's not VHS versus Betamax, where you had to pick a winner, and obviously one of those won and one of them lost. It's more like JPEG and PNG. They both exist. They came from different camps to begin with. One came from drawing images, one came from reducing photographs. They're pretty much, for most people's use, interchangeable now. There's tools that you can switch from one back to the other. And yes, for some real purists, one of them is better for their use case, and for a different set of real purists, a different one is better for their use case. But similarly, that most people could use either. And there's going to be several of those among this alphabet soup up here. But what we're going to try and do in this session is sort of go over the use case a little bit and show how the different piece parts here at a very high level fit in. And then in the later sessions today that sort of go around the wheel by individual session, we'll get into more detail on a given technology or given project. I'm not sure what to call them. Some of them are open source projects, some of them are standards, some of them are, I call them technologies for a while, but whatever all those little things are, we have a bunch of them, and we'll do them more sort of centric to people have brought some what we call sweat equity into the room. They brought some, hey, I have something that does one of these things. And they sort of get, some dedicated time to talk about their stuff, and ideally get it to hook with other people's stuff in real time while we're here. And so we're going to start by going through the use case at a very high level. I'm not going to read it. We'll throw some of the text up there. Hopefully you all have that link that's shown up there at the top. It was part of the setup for all this. Hopefully everybody's already read it. If you haven't read it, you can read it in the background. But the sort of purpose is to sort of break up the use case into a bunch of scenarios, or the scenarios. Some people claim it's not a use case because we don't follow all the UML rules on what a use case is. But whatever you want to call it, from a user's perspective, what's the value in a particular ransomware attack of this alphabet soup that we throw up here? In fact, usually I throw up an alphabet soup slide, and I forgot to do that. And the objective of what we're trying to do in this overall session, but what we're going to try and do within the next hour, is to work into those use cases the value proposition for the alphabet soup of the previous page. And some of that, when we'll get to the later sessions of the day, we'll demonstrate with actual, machine APIs. And machine 1 will talk to machine 2 and do the actual function. And when you get down to the gory details, you sometimes miss this big picture. So we're doing the big picture first of, hey, when we show you this Cacao playbook that sends this OpenC2 command that does this thing, why are you doing that? That's why we're going through in the next hour, the why we're doing it. And some of it will be actual, at machine speed automated stuff. Some of it will be human interfaces that you could use some of these tools. You can learn from it. How you can learn about the technology from using the tool. You could better understand, for example, Cacao playbooks by making some, as well as just from advancing the art. We'll be making some to that didn't exist before or got made just for this meeting to help everybody understand stuff. And then there's the infamous, what we call a LICAN or transformative software that doesn't exist yet, called the hand waving LICAN. And then there'll be some that'll be just like that. Yeah, this is supposed to hear, but it doesn't actually work yet. A prime example will be this Raspberry Pi not lit up that I'm holding in my hand right now. But I can get it to light up, but I can't get it to light up based on the OpenC2 commands. Although I do have a web version that will show you that we will do. So sometimes there's going to be this hand waving aspect to it. What we found over the years, this is depending on how you count them, either the 4th or 5th time we've done this, that the hand waving icons of the past become the actual demonstratable software of the future. Somebody says, yeah, we need to do this, and yeah, we need something that connects A to B, and then by the next time somebody goes off and writes some software that connects A to B or whatever. And in some cases it's just because they didn't update the software, which is why that little thing doesn't work like it used to. So anyway, big picture is had a writer help me with some of this, 6 days that show sort of 6 different aspects of what happens during ransomware and where the different alphabet soup helps. We're going to go through them one at a time. So I don't expect you to read the text in the middle, because I expect you looked at that website and read it before. And if you want to read it, you don't have as good enough eyesight to read it, you can go back to that link and read the details. But the purpose of this particular day, this day 1, when the 0 day happens, is Murphy's Law LLP is less impacted than the average person attacked by, or average law firm attacked by ransomware because they had the foresight to put in Kestrel, Cacao, OpenC2, Stix, TAC, IOB, and CSAF. We believe in some of the talks later in the day, the actual details of sort of, hey, I can do this to help. We'll talk about in more detail, but we think we cover that much of the alphabet soup. And one of the reasons for sort of going through this at the beginning is so sort of people see upfront the value of what this, hey, Duncan can send an OpenC2 command that makes the LEDs change color. What's that got to do with ransomware? Well, we'll get into the detail of the playbook uses it to mitigate attacks. So you're not turning on LEDs, you're controlling cybersecurity gear, but you can't see that. So that's why the LEDs are just more fun to see. But the other reason for doing it is so we can sort of walk down the line to get prepared for later in the day. And the first one's always going to take the longest. It's also, I think, got the most in it. As far as do we have people here who have, they have something to show in this particular area, make sure that people are actually on. And if they're not, we'll do some hand waving. And then have each one sort of looked at from the three symbols at the bottom, our machine-to-machine interface, human involved in doing something, or the infamous hand waving icon. So we'll start with Kestrel. I don't believe I saw any of there's some Kestrel. Oh, Shasway is on. Okay, good. So we have someone from IBM on. When we get to that session later in the day, we have someone from IBM on. I know we have some people from HII on as well that worked with them that have the OpenC2 interface to Kestrel. So we'll have some actual demonstration of, and Kestrel has been demoed at previous events of this as to how to do the threat hunting and the actual playbooks involved. And I think either attack or IOB or some of both have some Cacao playbooks associated with that threat hunting that we'll be going over later in the day. Made it across all the way. And then with a little bit of hand waving at the very end, the Murphy's Law submits some new vexes. We do have in the PACE SBOM vex session, we do have some examples of some of them. We don't actually have any automated, so some of what will be demoed later in the day will be the actual, machine-to-machine interfaces for a lot of the stuff on, I'll call it the left-hand 3/4 of the bottom row there. And then some of it will be hand waving associated. There'll be some human interaction stuff. And then from the automated viewpoint, it'll be hand waving because we don't actually have that I know of, a working PACE system as part of any of the demos that actually tie in the security attributes back into a Cacao playbook and do it derivated, unless we can somehow get some of Vaughn's stuff or Vaz's stuff to do that, which I don't think we can, but maybe I'm wrong on that too, because I do know we have some good Cacao playbook stuff. So we'll pause for a second and say, everyone sort of got a feel for how the stuff later in the day will fit into the day one stuff. My screen, see if anyone's chatting. All right, and we'll go on to day two. Day two is not too different than day one. It's just the 1 day instead of the 0 day. Slightly different from the user viewpoint. It's a slightly different aspect. Don't know how to do why that's doing that. Oh, there we go. I couldn't get it to go back. I was trying to, there was those little squares appeared. And I tried to get rid of them and it caused me to go forward a slide. I was trying to go back a slide, but not as facile with Google Slides as I am with PowerPoint. Slightly different keystrokes. Again, the details of day two are in the use case. Looks very similar from sort of the automation viewpoint. One of the differences here is more from the user viewpoint. Sometimes what we run into talking with the real users is, yeah, but I'm not, 0 days never get to me. This is the sort of everybody else and how it helps them. But from the actual playbooks and everything you run, it's a little bit more preordained because the Murphy's Law LLP sort of did the work of having to create that first playbook. These people then use it. And this is probably the more of the majority of the people, but hopefully even more of the people will be day 3, which is Triumphant Cleanup Incorporated, which don't get exploited at all because they took the trouble to analyze all this information that's being passed around in sticks and plug it into their PACE system. This is when PACE first appears in our use cases. Recall PACEs. I probably should have been explaining all of these as we went along. Hopefully people realize what they all are, but let's just in case there's anything missing. So Sticks and Taxi is the way, as Brett mentioned, to share threat information. Cacao is playbooks, way to share between either systems or organizations what it is you want to do under what conditions. OpenC2 is open command and control, the actual commands you send, so you can do them in a vendor agnostic way. It's opposed to the 17 different ways you can tell a firewall to block an IP, for example. Kestrel is I guess we went back a day earlier, Kestrel would have been first. Kestrel is a language for threat hunting and finding attackers that are in your system. The TAC technical committee is the threat actor context technical committee. So it's the information looking at it as opposed to as Sticks tends to look at indicators of compromise. You've already been hacked, and this is how you detect that something occurred. The threat actor context is more looking at it from the attacker, from the defender's understanding of the attacker, and what they're trying to accomplish, and what they're trying to do. Because it doesn't matter that from a Sticks viewpoint, they got in through the front door, they got in through the left window. From the threat actor context viewpoint, it's, hey, they're trying to get in your house, and it doesn't matter whether it's the front door, the right window, or the left window. So just because they didn't go in the left window yesterday doesn't mean they won't go in it today if the other 2 are blocked. And again, welcome. You here for Cybersecurity Automation Workshop? Oh, you're here with the food. Yes. We're going to take a brief second because I have to sign for the food. I will be back in a moment. Oh, no problem. Sign anything? Oh, hold on. Let me go over that. I'll get that. And do we get to keep the perks for the meantime too? Okay, so we'll just fill it back. And then, yeah, we'll have to switch the stuff onto the table. We don't get to keep the cart, so we're gonna move it onto the table. Oh, thank you. We'll give you the cart right back. Hold on one second. Thank you. Well, you're bringing us food, so thank you. So we'll break into that. Just leave it for now. We'll break into it at noon. But where was I? Oh, so the threat actor context, I think I explained some, and we're about to get on to indicators behavior. So again, similar to Sticks was looking at it from a compromise viewpoint. Indicators behavior, looking at it more from a behavioral context viewpoint, and ties well with the threat actor context. So one is what they're trying to accomplish, one is how they go about doing it, and the third is what you actually see as a result of that. Then CSAF is the advisory format for putting out in the particular context that we showed here, or in the first case, the vulnerability of certain exploits in your software, or the VEX as it's called. And then so back to day 3. So this is, hey, they're not under attack. You're going to do some preventative work. You're going to use your PACE system, which is the posture, attribute collection, and evaluation. The posture that we're talking about is security posture. One of the main components of there's lots of components to your security posture, but one of the ones being demonstrated in this use case is from the software bill of materials. Do you know what do you have an inventory of what software you have? And more importantly, do you know what vulnerabilities they're susceptible to? CSAF with its vulnerability exploitability exchange, as we mentioned, the other one can tell you, hey, you don't need to worry about this particular exploit against this particular software, even though it has a CVE against it, or you do need to worry about it, and here's what you should do about it. And so in this particular case, the Triumphant Cleanup Company makes use of the fact that they know they could potentially be hacked, that there are attacks in the wild going on, all that information from the first 2 days. They go look at their inventory of devices, decide that, hey, particular subset of them can be attacked by this particular type of ransomware, the exploits that this particular type of ransomware exploits. Once they get into the details of it, though, they discover that about roughly half the devices that they thought were potentially vulnerable actually aren't, because the manufacturers have said, hey, they have these vexes that say they're unaffected, but that the other ones are affected, and those they have to get in there right away and patch. They were intending to patch them eventually. Now they're going to do it more quickly, and that prevents them from being attacked at all. So that's sort of the day 3 scenario. Introduces the PACE and the SBOM that weren't in there before, and makes use of the VEX again, as well as the Cacao, the sticks, and the OpenC2. And then day 4, a fictitious government agency with a funny name that's part of a larger department in the US government with a different funny name, has this particular edict that actually many federal agencies are under on comply to connect. In other words, you're not supposed to stick stuff on your network if you don't know it's in compliance with your rules. So as a result of all that stuff that went on in days 1 through 3, this particular agency updates its rules to prevent devices from attaching to their network that haven't already put in the patches that were as a result of this particular type of ransomware. Again, involves mainly their PACE system, because it's your security posture. You're updating information about your security posture based on these particular vulnerabilities and the state of them. But that makes use of your CSAF, makes use of Cacao playbooks to go run all this stuff, and run OpenC2s to do it. And you've got all your commands in the first place from sticks. And then you have, you're making use of your software bill of materials of the devices you already have and the devices that are going to be brought in. And then we introduce a new project in this particular scenario. This one will be a total hand waving one, which is the NEEM Open, which is a recent activity that moved from the federal government into OASIS to standardize on basically the terminology, the taxonomy, and the ontology of the information content of the cyber information associated with these vulnerabilities. And in this particular scenario, it's used to for the federal government to share that with the state and local and tribal territory governments, so that they can do similar to cleanup or Triumphant Cleanup in the previous slide. And apologies, my screen's going a little nuts up here. I'm not sure why. And pass that information on. So most of the stuff up until this point will have sort of actual, if we don't have a working demo of machine 1 talking to machine 2, we'll at least have, well, here's the data that machine 1 created, even if we don't have a machine 2 to listen to it or whatever. Or conversely, here's the data machine 2 can absorb, even if a human had to create it. But in the case of NEEM Open, we don't actually have, nobody brought any of those as part of sweat equity. I had intended to do some of that, but I had just not gotten to that myself. And then day 5 is going to again be a total hand waving day, which is law enforcement gets involved because it was criminal activities did occur. In this particular case, multinational takedown occurs, and they did that by sharing these NEEM Open MEPs, message exchange packages, if I remember right, that are the sort of way they're quite in heavily use in the US law enforcement community and in the courts of the United States and allied countries as far as ways of exchanging data, not just associated with cyber attacks. In fact, they mainly came about associated with car accidents and speeding tickets and agriculture and lots of other things. And they're now getting into using it for cyber attacks as well. So again, nothing that I know of that will actually demonstrate as part of this, but it's still part of our larger use case moving forward. And if we can, either I find some time to do it, or we get some more NEAM people involved, future ones of these, we can get. Can I? For the people on the remote, somebody chatted in. Okay, yeah, something's going on up here that's like blinking on and off. I'm not, that might be the reason also. This one was, see, this is doing this. So I don't know if that's affecting, I don't know if something's cutting in and out, or if it's just I didn't talk loud enough. All right, it's probably just me not talking loud enough. That's a rare event, me not talking loud enough. But anyway, so day 5 is probably a little bit beyond our headlights for today, but we're setting up for future, and at least with some hand waving, people can see it. You can see there's no machine to machine and no humans on the bottom there, just a little hand wave. And then day 6 is totally out of scope, but we threw it in there anyway, because in this particular attack, it was decided that we can either confirm or deny whether there were rogue nation states were involved, and we can either confirm or deny that the same NEAM open stuff is used by the US military and NATO allies in their hunt forward cyber operations, and whether that got used to take out the actual bad guys or not. So again, even once this becomes part of scope, it probably won't be in scope of this particular meeting. But NEAM has some classified extensions to it that the military uses. Basically the NEAM open part just sets up the ability to do stuff. The actual extensions they use to do the stuff up there, we don't have weapons and things like that in our open inventory. But anyway, that one's will be a total hand waving as well. And so that's sort of looking at the days from looking at the use case from a sequence of different actors and their perception of how these different tools can be used to improve their lives. And then the sort of summary of that, if I did it correctly. So this table sort of read the 2 middle columns as and then each middle column goes with the outer column that goes with it. Sorry, it's a little weird once I made it, but it was a pain in the butt, so I didn't want to change it. So I believe today that we will have some actual Kestrel, real work being done, machine to machine interfaces that'll occur even between organizations. There is a human component to it. In other words, you actually, humans are involved in the threat hunting. And I don't know how much we'll get into that detail today, but it's at least possible. And then because not everything's perfect, there will be some hand wave. All of these have some degree of hand wave, because whatever we do, there's possibilities we could do more. And so we'll just wave our hands and say that. Similarly with when we get to the cacao section, and these are not in the order we'll be doing them, they're just in the order I threw them on the slide. When we get to the cacao section of the talk, we will have some, believe we have 2 different organizations that have brought some, or maybe 3, I think. There's 2 that have bought systems that make use of a cacao, and at least a third and maybe more that have brought the, here's what we need, here's an actual playbook and what we needed to do. And so again, there will be some actual machine to machine stuff involved. There will be a fair amount of human involved. There'll be some, hopefully we'll have some time for some demos, and I believe we'll have the capability for sort of anybody who wants to get in and try and make their own playbook to do some of this stuff. In the OpenC2 section, we definitely have some OpenC2 from one organization sending to another organization associated with the Kestrel part of the demo. We have a different part associated with the PACE part of the demo. We have different associated with just that very first, I guess all 3 days had some various, hey, you just send some commands to mitigate some activities. So we have several organizations that have one side can send and the other side can receive. I will have to say, since some of that stuff is mine, there will definitely be some hand waving. There is some that'll actually work. We'll go over that. But the actual blinking light at the front here, unfortunately, I don't have set up to actually talk. I can make the lights light. I just can't make them change color based on MQTT commands. I screwed that up. A lot of the still keeps being up. I think part of also issues is just I'm bored staring at the computer and talking. So I aim in other places. And when I'm aiming in other places, I apologize to the remote speakers, remote listeners, that they don't hear me. Because they certainly can't hear me audibly because we're hundreds of miles away. So Sticks and Taxi, again, plays a major role in a lot of what we're talking about. There will be some actual Sticks and Taxi objects that will be discussed in many of the use cases. We do actually have stood up for today a taxi server that we can actually exchange Sticks objects between organizations. So that's good. Again, when we get into the tax section, we'll go over some of the actual data that will go into Sticks based on some of the use cases we're talking about. Similarly with indicators behavior. CSAF, we do have some actual VEX. There are, I think, at least 3 actual, but all from one organization, me, VEX documents that were created associated with that. SBOM, there is again some software bill of materials that were created for some of the various projects that, I'll say almost incidental to the rest of what we're doing, but the tools themselves actually have, sort of drinking your own champagne, actually have SBOMs that go with them that we can use as part of the examples in these scenarios. NEEM Open will be a strict hand wave. There aren't any, to my knowledge, actual pieces of data or any systems that do that for today. And then the other 1, 2, 3, 4, 5, 6, the other 6 alphabet soup acronyms on there. To my knowledge, nobody brought any sweat equity to today's event. Any one of those we could work into the use cases, but we're sort of not going to focus on them because we got enough other stuff to focus on. But if people are interested, we need to, one, get some more people. I'll have to say there's at least one person for every one of the projects up there, because I'm actually involved in every one of the projects up there. So, but I can only do so much. So I chose not to personally put any effort into the ones on those in that box. And we'll have to get some more people involved for the next time we do this. But if people do want to, we do have some time at this point. So I'm pretty sure that's it for me, right? Yep. So if people did want to go over, wait a second, how does Kestrel fit into day one? Or wait a second, you sure you could fit, spider risk into this? Well, what's it got to do with anything? I am happy to open the floor to questions if people want to explore any of these in more in depth before we get in, particularly the ones that we aren't going to get into more in depth on later in the day. So particularly the ones in the lower right of this. This will be the last time we'll talk about any of them. So if people want to discuss any of them, now's the time. That's why we allocated more time. And we can also get into some of the other ones, because again, we get into we won't have lots of time for each of the projects later on. So if we want to get into the, hey, what is it again? Or what are you going to show? Or what's Fawn's tool going to have to do with cacao? We can cover some of that now, so that when we get to the other actual segments, we can sort of dive into the details quicker. So with that, I will open it up and ask anybody want to go into anything in more detail. Or we want to be ahead of schedule. We're allowed to do that too. Go ahead.
General question. How far into the future? There's a lot of hand waving, but in your mind, how do you get from today to some of the
So I'll repeat the question first for the audience, and I'll make a crack at it. Then other people can chime in if they want to. So repeating the question was, how far, I'm going to reword it as, how far away is any of this? How much of this is near? How much of this is far? When do I foresee it occurring? And then we'll let other people answer that too. And the answer, like many answers, is going to be it depends, because it depends on which one of these you're talking about. Some of these, like spider risk and OXA, got literally created in the last 6 months. So we won't expect them to be, up in production right away, but maybe they will be, because like OXA is an EDR system, so it's a hot topic at the moment. Some of these have been around for a while, but haven't really caught on as much. There were some studies done with OpenC2 5-ish years ago now, just showing the pure economic value of doing it. But it's all said and done, not in most vendors' interest to make their interfaces vendor agnostic. There just needs to be more customers screaming for it. And they're starting to scream for it. Neil Ziering, tech director of cyber at NSA, at last year's Borderless Cyber, announced that he expected to see it in federal procurements by the end of next year. Using SBOM as an example, I've been pushing SBOM since around 2002, 2003. Obviously not very well because it took this long to catch on, but it is beginning to catch on. And that sort of federal procurement thing, when the federal government announced 3 years ago, it was going to put it in all FDA mandated medical devices, it would just take a while to do it. And when President Biden put out Executive Order 10428 in May of last year, that basically said, hey, federal government, we can't make anybody else do it, but we can at least say we're not going to buy anything unless they do that. All of a sudden, boom, the SBOM-ARAMA, which is tomorrow and the next day, unlike this group of people, is going to have 100 people in the room and it's going to have 900 people online. And the 5 years ago when we started the SBOM NTIA work, it was actually smaller than the amount of people in this room. So it does take a number of years, and it's really when the thing takes off. Sticks has been around a while. It took, as Brett mentioned, it took us a couple tries, the round one and round two. Brett and I were in the minority on round one. They eventually came around our way of doing it round two, but it is now in quite wide use again, in particular niches. And niches happen to be, how the federal government shares threat information. So it's a pretty big niche, but it hasn't gotten as wide. It's just sort of beginning to make the curve as wide to the rest of the world now, because it's like Brett mentioned earlier, but now what do I do? You need some of this other stuff to determine what to do. So, so my gut is 5-ish years from now, we'll look back and be amazed at what do you mean you didn't do all this all the time? I don't get it. Why didn't you do this 10 years ago? It's because it sort of took it all sort of gelling and coming together. I do think Executive Order 1428 is a sort of major impetus that will actually sort of make all this stuff much more useful. The U.S. government came out with its national cyber strategy in April-ish. It came out with its national cyber standard strategy in, I guess it was late May, maybe early June, I forget. It wasn't too, it was like weeks ago. It was not all that long ago. Those events, I think, will actually start literally changing the landscape. And it used to be, hey, it didn't make that big a difference because we weren't really losing that much money and no one was getting hurt. Now we're losing lots of money, and unfortunately people are starting to die. So I think it's going to hit a curve, but it's still going to take us a while. That's my opinion. Brett, I'm sure you have an opinion, but you got to come up to the mic.
Really fantastic question. Like, where are we at and how much time in the future is it going to be? So give me a little bit of context. It took about 8 years to get Sticks and Taxi done, and it was finished in June 2021. Yes, we did 4 major revisions in that time frame. So there was the 1.0, the 1.1, the 2.0, and the 2.1. And that is lightning speed relative to something like the IETF, where it took TLS 1.3 10 years to be done. So, but now, like with Sticks and Taxi, that is very commonly used. All of the ISACs and ISAOs share their threat intelligence via Sticks. There's tons of products and tips and everything supports Sticks today. And like I used to joke with Oasis, even though they don't like me to say this, is if Sticks and Taxi is really successful, you'll never even know those terms because it'll just be ubiquitously used everywhere. And so the DHS AIS system uses it. There's stuff in Europe that's using it. The UK is using it, and tons of products using it. So that's really 2 years from the time it was final. So from June 2021 to now. And yes, people started working on it and started implementing it. But now that it's final, yes, there'll be some minor tweaks over time, but it's being used. And so Cacao started much, I don't know, was it 4, 5, 6 years ago now? And it's really kind of gone through. It's did a 1.0 version. Now we're at a 2.0 version. And Cacao is going to be this mechanism that's going to enable things like OpenC2 to be really used. Because OpenC2 by itself is kind of like Joe Brule, who started this at NSA, always had this view that all of the decision logic had already been made. Now you just needed to execute the command. But there was nothing that glued the OpenC2 stuff to the the graph model of sticks. And so you have all this threat intelligence, you decide, you make the decision, but there was nothing that connected it. And so that's why we did cacao. So there are products today that are using cacao, commercial products in production. There are huge initiatives at the government level to do this, and you'll start seeing the cacao playbooks probably show up in trust groups and through ISACs and ISAOs. We designed cacao to plug in very nicely with sticks and to fulfill the role that the course of action object in sticks didn't do, because the technical committee had no desire to do it. I chaired both groups, so I was the lead editor on both. So cacao is going to fulfill that role, and there's already momentum for it, which is then going to enable more things like Kestrel and OpenC2 and some of these other things that are going to be downwind. And we'll talk a little bit more about cacao in that section, kind of go through the various playbook types and step objects and how it relates to BPMN and give some real examples. But that work is moving. And so I think Duncan is right. For the whole picture, we're probably about 5 years. But for major parts of this, we're probably in the 2-year time frame before you're going to start seeing some of these pieces in widespread use. I know there's a project in the EU to use cacao to be the early warning system for all member states in the EU. There's been a greater interest and involvement by MITRE and DHS and NSA with cacao as of recent. So you're going to start seeing this kind of come out. So, we're still a little bit on the cutting edge, but it is definitely coming. And there's really cool products. And like Sidearm here, we have the CEO of Sidearm here, and their product today supports cacao. So some really cool stuff.
And I think there's a famous quote, I think it's by Gibson, but I might have it wrong, but is the future is here. It's just not evenly distributed. That's there are pockets of this already occurring. There's pockets of it that some of it that have occurred. It's just the going mainstream. I think it really does take the putting them all the piece parts together, which is what we're doing.
And the government stuff, those will adopt first because they have a much higher risk and less tolerance. And so this will be very useful for them. And then it'll get out into the enterprise. And just kind of
All right, other questions? Yeah, I just popped that. I just because I can't see the chat when I'm up here. I just decided, well, what the heck? I'll just display it the way I can see it. It's in the chat, but Neil's keynote at our last event is on there. And what's that saying? Oh, good. That's for some later stuff. All right. Any other questions or comments? First of all, anybody else want to comment on the previous question before we move to new questions? And hearing none, yes. Any other questions? Anything people want to go in more detail, or do we want to break a little early for lunch? That'll give some of us time to get the rest of our stuff for the afternoon better prepared, and we can maybe then start a little sooner too. Pop up the agenda. Why is it not going? So currently we're scheduled to be back at 1, but if we were to break now, we could be back, say, at give people a little more time for lunch and still come back early. So come back at 12:45. Does that sound reasonable? All right, and lunch is in the room for here. And let me see if I can exit full screen and change this so that people will see that we're coming back earlier if people aren't on. Back to slideshow. There we go. Let me hit the mic. Let me
This meeting is being recorded.
All right, we have started the recording again. Welcome back, everyone. We're restarting a little earlier than the original schedule since we had a longer lunch break. Hopefully everyone is back. Quick, grab the participants. Anybody not here, speak up now. I guess more importantly is I will turn it over to Dave and Matt. I see we have dual wranglers now. For the next section of the agenda on OpenC2, Jaden, Kestrel, and Stick Shifter. Take it away, guys. I will shut up and let you guys talk.
Okay, thanks, Duncan. Next slide. Well, the second next. Okay, thanks. I'm going to have one quick slide about OpenC2 itself, and then turn it over to our HII team to describe the work that we've been doing with IBM on threat hunting and Kestrel. But OpenC2 itself is the language of OpenC2 is a framework. It's just the plumbing for getting messages back and forth between orchestrators that control devices and the systems or devices themselves. It's a fairly simple framework, but it allows interoperability for any kind of messages. The messages themselves are defined by actuator profiles. And so they capture the use cases, the requirements for controlling specific cybersecurity functions like endpoint threat detection and response, or threat hunting, mitigation measures like isolating compromised components, remediation, actually updating or reconfiguring a system to reduce the vulnerabilities, controlling, traffic routing and filtering that goes on. So those are all where the interesting work happens. The profiles define the use case specific things that OpenC needs to do. And so designing an actuator profile requires subject matter expertise in each of these cybersecurity areas. And so, we can participate in designing a standard interface for performing these functions, but we can't do it without the people who are actually doing it every day. And so we've been lucky to be working with IBM with their threat hunting expertise, and they've brought a lot of maturity to what we've been working on. Once you define what you want to accomplish, then a schema defines the messages that you send back and forth to do that. So we're using schemas to both write the actuator profile documents themselves, and we're using them to validate messages that are sent across the wire. And so by doing a schema-based design, we can ensure that the standard specification is in sync with what the endpoints need to be able to process. And so we've got a software repository that we use to help develop the actuator profiles. We have a set of devices that support specific profiles. We have test messages that we send to those devices to make sure that both to design the messages themselves and to test interoperability or the ability of the devices to process them. And we have some support functions that we can use to actually test that the messages are conform with the schema. And so there's a link there for where to find that. We've got, in addition to that set of development support, we've also stood up an MQTT broker to allow us to do testing virtually rather than requiring everybody to be in the same room for the Plug Fest. And we've got the documentation on the bottom link there, tells you where to find information to connect if you have something to do that. I wanted to share my screen if I could for a bit. Let me try that. We were just playing around with, I guess Duncan is going to introduce a twinkly device that's kind of a Hello World LED controller device. And we have been playing with that, and the interfaces for that are not really well defined. And so we've been playing with different kinds of commands, trying to get the hardware that we've got working with what we have or don't have written down. And so you can't just specify what you want to do by word of mouth. You actually need to have examples and documentation. And so the variety of things that possibly could work just for this trivial Hello World application are shown up there. And some of them actually did work, and HI does have an LED controller, a virtual controller available when Duncan gets to his Hello World part of the presentation. We've also got a repository, again, like I said, of commands and a way to test the commands against the schema that we are creating in our OpenC2 documentation. And so if we run it, it runs, we have a collection of devices that support various actuator profiles and a collection of messages that those devices are supposed to support. And so the script will run through each of the devices and run through a set of test vectors that we've got to try to test them out and see where they work and where they don't work. And we've got, as this shows, we've got a lot of work that we can continue to work on. For example, we've got a simple SBOM retrieval profile that we've started developing, dusted that off after a couple of years of inactivity, and are starting to work on that again. We've got most commands are working. We've still got insufficient documentation. We've got a set of good commands, a set of bad commands that are supposed to fail, a set of responses that are supposed to succeed, and a set of responses that are also supposed to fail. And so we've got a couple of simple commands. One of them works, one of them doesn't yet. Most of the responses are not working because we don't have sufficient documentation. So this script will allow you to put together the information you need to ensure that the profiles that we're working on will actually work in practice, and then that they will perform when we try to connect one developer's producer to another developer's consumer. And so that is the way we are doing our work when we are trying to achieve interoperability. So with that, we can get on to some real results working with the threat hunting team. And Matt, if you can take it over.
All right, this is Matt. I'm with the OpenC2 team. And before I jump in, we have Larry Feldman. He wanted to give a little bit of background as well, and then he's going to pass it over to Kevin. Kevin's going to give a conceptual design of what we're going to demonstrate, and then we'll get into sending some commands and seeing some communication back and forth between devices. All right, over to Larry.
Good afternoon, everyone. in addition to what Dave shared with you, I would like to say that in our cybersecurity automation use case, we're supposed to explore how Kestrel, OpenC2, and Kakao can be used together to create an integrated and efficient cybersecurity workflow for detecting, responding to, and mitigating a cyber threat, such as ransomware attack. We would like to use command orchestration based on Kakao playbook and threat detection based on Kestrel software and libraries of hunting books. For today, our major goal is to demonstrate how OpenC2 could be used in conjunction with threat analysis tools and with mitigation activities by providing standardized implementation agnostic commands that perform command and control functions. We still working on good connection with Kakao playbooks, and we're trying to, in our case, to simulate some kind of request, and we'll maybe in future provide more clear connections to playbooks and connect Kestrel with Kakao in more efficient way. Kevin, please tell us what we're going to do today.
Thank you, Dr. Feldman.
Tell me if you want me to be clicking slides.
Can you hear us okay? Yes, I think we want to go to the next slide.
And yes, we do hear you.
Okay, thank you.
Hello, this is Kevin Cressman from Products Engineering here. I'm currently on docket to talk for the team. Most of us are here today. We're missing the illustrious Dave Lemire. You just heard Dr. Feldman. The rest of the dev team is our team lead, Matt, myself, Caitlin, and Kalum. Next slide, please. And we're very excited to show, this is a slightly updated version of the more general use case Dave Kemp was just showing off. We discussed this with Mr. Jordan, and we came to a slight tweak to more properly describe actual use of a implementation of some sort of monitoring system like this that runs periodically, but all the steps are generally the same. You'll notice, if you can go to the next slide, that everything over here it maps very nicely to a Kakao playbook. And for our purposes, we would like to use these as individual atomic playbooks of a playbook in the very top left that calls out to this anomaly detection using an OpenC2 endpoint response actuator profile. And then depending on the results from that call, using an OpenC2 command as that blue arrow, you'll notice a large number of those, falling down to this analysis of data with a Kestrel runtime using the threat hunting actuator profile and OpenC2. Similarly, OpenC2 commands out, OpenC2 responses back into an understanding of the Kakao. Following that is going to be some sort of hybrid approach, a Kakao playbook implementation that is run by a security team that first alerts them, and then they may kick off a remediation or a mitigation activity. A number of those are on Kakao's examples repository. There's a number of them in various stages of aspiration, I will say. And then each of these feeds their results into some sort of log, stores it into a posture repository database. It could be anything. Elastic, MariaDB. I think our internal OIF uses a MariaDB, but it could be anything, wherever your data wants to be, and then resets periodically. Next slide, please. Narrowing in just on that playbook centered command generation, we have a very sketched out versions of playbook logic for that first, second, and third Cacao playbook. We'd be very happy to implement some actual Cacao into this for down the line. But for now, we just have general logical steps that we check with some people who know a little bit about Cacao. They might say about themselves. They want to raise their hands. They can let us know. But they generally these logical steps are things that could be implemented in Cacao just with a little bit of short notice. And all of them are producers in a general sense of OpenC2 commands to a OpenC2 actuator profile. And so it has a command, generates that command, sends it out, is received by something that has that OpenC2 actuator function, sends a command back, and then depending on those responses, handles it, and then either logs it or goes to the next playbook step and logs it. And so for playbook 1, playbook 2, and playbook 3, they're each OpenC2 commands out, OpenC2 responses back in. And then when we get all the way down to the end, it is a periodic thing. It can be reset to run every, big air quotes, every hour or whatever amount of time we have this in. And then go to the next slide. As I said, we have logic, but not actual Cacao at this point. We have a way of mimicking it through a relay of an OpenC2 command that Matt is going to share off towards the end of this, how we do that. But at the very basic level, all of these are going to be OpenC2 commands produced by our OpenC2 integration framework OIF orchestrator that goes through Dave Kemp's MQTT broker. We are going to be sending our commands over MQTT v5 and serialized in JSON out to this series of a variety of OC2 enabled devices, a Yuki OpenC2 consumer proxy that's pretending very, very fuzzily to be an endpoint response device. Matt and Caitlin have a variety of OIF and Kestrel things that are doing Kestrel runtime, using an OIF device with the threat hunting AP. There was an idea of using Duncan is going to be showing off blinky board functions. That could be, if you look at it a little bit sideways, that could be an alert to a security team, but in other ways, this could also be something hitting a Slack API or something like that. We don't have that in, but there's gonna be blinkying later. And then all of this goes into storage into your various database. Next slide, please. I think this looks like the previous one, but next slide there. So this is just a zoom in of an individual one. These next three are going to be very quick, and then we're going to be throwing back to Matt. This is just at the zoomed in level of OIF to a single device. This is a view of the Cacao playbook logic using OIF orchestrator to send an OpenC2 command to the Yuki proxy to perform scan functions. And here is an OpenC2 command that we'd be using for something like this. And then the next slide is going to contain the same, but with threat hunting. This one sends for a predefined Kestrel threat hunt that's integrated with Elastic in at least one of the implementations. It's going to be hunting a process named node and on a specific PID, and then bringing back sticks data. And then on the next slide, we just have a very vague, and as Dave Kemp was mentioning, the blinky board logic is a little bit in flux, but this is a command we were planning to send at some point in the evolution of this. And then we'd like to throw to, I believe, Matt and Caitlin for a brief discussion of OIF and the actual things that you'll see here.
All right, terrific. So now we can actually send some commands and see some fun here. Caitlin, if you would bring up the OIF and share that screen for me. The OIF stands for OpenC2 Integration Framework. It's an application that anybody could pull down and fire up. It allows developers and people that are curious about OpenC2 in order to play with it. You can set up your devices inside of the orchestrator. You can load in your OpenC2 schemas. And for instance, we have a threat hunting schema that we've been working with Kestrel on. That's a generic threat hunting schema that we're going to use today to send some commands. And then you can build your command, which is the page that she's on right now. We're going to be interacting with a number of different devices. And we're doing that to demonstrate how OpenC2 can interact with just about any kind of device. This first one is a homegrown application called Yuki, and it is running on a Mac laptop. It basically just going to receive a command, do a query on some sticks data, and return sticks data back to the OIF. After that, we're going to do some commands against a couple devices that are set up to interoperate with Kestrel. And it'll take Kestrel commands, do some hunts, give back some hunt data. And that's on 2 different devices. One of them is running Ubuntu, and the other one is also a MacBook. And at the very end, yeah, we'll do a relay, which is simulating as if Cacao were to hit our OIF, and then the OIF were to relay out to the devices to do a Kestrel hunt and then give data back, which we could then view in the GUI. So that being said, Caitlin, I'll let you take it from here and send off a command to Yuki.
Hello, maybe.
We can hear you, Kayla.
Okay, cool. All right, so I already have the scan device Yuki command ready. Kevin, if you have Yuki up and if you want to share your screen for your logs, everyone else can see the response that Yuki would respond the command with. Not sure if Kevin's screen is sharing or not.
I think we can only see one screen at a time.
Okay, well, I guess we can just stay on the orchestrator then. I will send it and you can still see the logs coming through the orchestrator.
You can just send the command, and then Kevin switch the screen, and then we
Yep,
see the Kevin screen.
We are ready to go. Kevin is
Alright.
sharing his screen. Sorry, we
Okay.
had trouble finding the mute button.
Alrighty, so if you guys are looking at Kevin's screen, I'm sending the command now.
Okay. Yep. It looks like we got it. Did you get anything back, Caitlin?
Alright, so if we can go to the logs of the orchestrator, you can see the command that I sent to Yuki, and you can see the results that Yuki returned. So this is all the sticks data from Yuki. And now from there, I'm going to create a threat hunting command.
Yep, we're gonna jump over now, and we're gonna hit 2 different devices now, like Caitlin's saying. So Kalam, get ready.
Yeah, I'm ready.
This command is supposed to return all the hunt books available on both of the devices. Kaloum, Matt, you guys ready?
Yep, Kalam, are you sharing your screen?
Yes, I can share right now.
Okay, go ahead and share.
All right.
Can you see my screen?
Yet?
Kaylin may need to stop sharing.
Oh, sorry.
There.
Okay, now try
Alright.
again, Kalam.
I'll try it. Okay. Can you see now?
Not yet.
No, yeah. Okay, let's see.
We may be able to have Matt share his if this
Can you
is
see the screen?
currently no.
No.
Oh,
Here, how
Let me
about
see if I can find it.
Matt shares his, because they're both running very similar Kestrel runtime, actually.
what about now?
Yeah, now we're good.
Okay, now we see your screen. Alrighty, I am sending the command. Should be sent.
Yeah, I receive it.
All right, very
Yay.
good. Received the OpenC command, and it did some work. and it returned back a response back. All right, great. Caitlin, can you share your screen?
Okay. Hopefully you guys are seeing my orchestrator again.
I believe Kaloum will need to stop sharing his
Yeah.
screen.
Oh, yeah.
Alrighty. So if you can see the log, this is the 2 responses, both from Matt and Kaloum's devices. The status 200 and the list of hunt books that are available on both of their devices. All right. All right, we're going to work on our second command. We're going to perform a hunt via the Kestrel stick shifter. So let's create that. We're going to do an investigate hunt given this hunt path. Oh gosh, all right. And if we want to shift back to Kaloum's screen, we can see the results on his log. All right, sending. You ready, Kaloum?
We have liftoff.
Woohoo. So if you see at the bottom of his log, you can see that there are 153 hits.
Very good.
All right, pan back over
We know it's a
to-
real demo because there's warnings.
yeah.
Yeah.
That has to do with our HTTP versus HTTPS connection with Elastic.
Yeah.
That
So if you
cleared
want
up the warning. Go ahead. Caitlin.
we can pan over back to the orchestrator. You can see the 2 responses, both from Matt and Kaloum's devices, all the results for that command. And we're going to perform one more command. It's going to be a test hunt given the string variables where name equals bash and the PID equals 1333.
And this one is tagged into actual Elastic data as opposed to a sticks bundle, correct?
Yep, that's correct. Yeah, this one and the last one both hit stick shifter and Elastic data that had Black Hat data loaded into it that the Kestrel team gave us. So thank you, Kestrel team.
Alrighty, so I have my command ready. I guess we'll go back to Kaloum's screen. And if we can see Kaloum's screen, I will send the command over. Ready?
Yep.
All right, sending.
Alrighty.
All right, you can see all those data in there. And now I'll share my screen again for back to the orchestrator. And you can look at the log and see the responses again from Matt and Kaloum's device, where all the results should have the name equals bash and the PID equals 13333. All right, now we can go to Matt for the relay command.
Yep, we'll kick off a relay command. Let me know when you see my screen. It will start.
I think it's just cherry bomb, right? There we go.
Doesn't look kind of. This looks black.
Yeah, it's pretty dark.
I will
That's
say
not good.
I do enjoy simplicity in design.
Let me try that again.
Is this the dark web?
Yeah, it sure is. Let's try that again.
Now, we've heard all those stories about MacBooks and Zoom.
This looks more promising.
This would be interesting.
There we go. Oh,
Okay,
There
this
we
is
go.
interesting. So I have just a really simple pub sub application that's going to simulate a command very similar to how Cacao would be sending a request to the OIF. And once the OIF gets this command, it'll relay it over to the devices to get data back from all the devices, then collect the data and show it in the OIF. And I'm going to hit enter, and off it goes. And pay really close attention to the request ID. This is what helps us track and collect the data. As you can see, it ends with 86BF. That's usually how I cheat and keep track of a request ID. So now if we go over to Caitlin's OIF, she could show, hopefully, the responses back from the devices that it collected data from.
Ah, we see a 86BF highlighted.
Very good.
Kelly, we can't hear.
That's okay. So yeah, this is.
Oops.
Go ahead, Caitlin.
Hi. Anyway, so here are the two responses from the standing devices on Matt and Kulin's machine.
All right. So that's all the commands that we were ready to show today. I would like to maybe post in the chat the topics that we use to do the relay. So that way someone else could interoperate with us and send commands and get some data back. We will keep our devices up and running so that anybody could communicate with us. Or if you want to just try and reach out to us, I don't know, maybe the chat will be available. So back to you, Dave.
Or to Duncan to
Duncan.
introduce. I think we're done.
Okay, awesome. I didn't know if we had questions or anything like that. I'm not sure how to wrap it up.
I would like to throw a fast mention that while we are doing a lot of this work in the threat hunting AP, we have a meeting series ongoing for the development of that AP on every other Friday. So unless people are very busy this Friday and Friday 2 from now, we'll be trying to take input on that. And if anyone has any ideas for how to help us have our Cacao to OpenSea to manage functions, including threat hunting devices, happy to work on that today.
Okay, Duncan, back to you. Thank you.
Duncan, you might be on mute.
Oh, because
Yes, we can see you on mute now.
all right, sorry about that. Talking into the wrong one. Let me turn down the other one now. All right, too much audio coupling here. We are using up a lot of the leftover time, but if we could take just another minute or more on OpenSea2 and the various things, I'll just do the 1-minute version of the S-Rifle stuff. So the people in the room can see a Raspberry Pi attached to an LED display that is not lit up in lighting because I managed to totally break it last night. At least had it so it blinked even if it wasn't under MQTT control until I tried to fix the MQTT and I think broke the hardware. So proves it's a demo because it doesn't work. But what I do have, I'm going to share from my computer. What I do have is the web equivalent, something called Twinkly Maha. In fact, I will keep sharing on this one. I'm going to pause for a second and send it in the chat so that I can get to it from this computer.
I'm talking for myself.
What's that? If that one were to send, but I still got my. That's the one link. So instead of an actual Raspberry Pi with a bunch of LEDs on it, this is a web server up in the Google Cloud that is the digital twin of the Blinky. So Blinky is an actual piece of hardware. Twinkly is a web interface interconnecting it. And it just changed colors. So other people have went to it and clicked the links. So one of the things that's true is there is only one server, even though there are lots of people. And so you can actually send MQTT commands to this, and you can send it from, now I gotta get the chat back. Which it looks like somebody else had already done. So they're doing the demo for me, but that's okay. So this is sort of equivalent to the OAF, but not really anywhere near as fancy and really stripped down at the moment. It's supposed to be sort of my equivalent to talk to my various projects, but right now there is only one project, Twinkly Maha, and there is only one broker. I happen to be using the Mosquito Test Broker. And then you can send a command like turn the LED on or turn the LED off. So if we go look at it, if no one else does this in the meantime, see, the problem is if anybody else does it, you can all, I put no authentication on, so we could all demo it and anybody could play with it. But the lights are currently on. If I go over to here and select the command, turn the LEDs off, I send the command and I go back over and the LEDs are off. And yes, there's logs and you can go underneath and see the sort of cool commands that the other people were showing before. And in the ideal world, we'd have their OIF talking to my Twinkly and my test box talking to their Yukis, and we can get quite that far, although we have done close to that. But again, we'll get there next time. But again, and in the ideal world, we would have done it with the actual lights blinking in the room here. But life got in the way. And we've eaten up 5 minutes of the extra. We can turn the other next 5 minutes over to the, oops, share to the slideshow. To whoever is next up, and at least give Cacao an extra 5 minutes. So with that, we'll turn it over to the Cacao crowd.
So we have some demos to do today, some people to go through and talk about. I wanted to give a quick overview of Cacao, and so I put some content into the slides. And then we have Vaughn here, and then Vasilios will do some stuff. And we already saw a little bit of work that was coming out of, is it HII? Is that HII? Is that how you call it? They're doing some great work, and I've had some discussions. I just been super busy, and so it's been hard for me to get everything done. But so the purpose of Cacao is to connect the dots. Like from a threat intelligence standpoint, we have all this great threat intel, but then it's the question is therefore now what? And that is the purpose behind Cacao, is to be able to take this stuff and then to do something in machine cyber relevant time. And this is why, right? The normal process is really slow when you have to go through and talk to all these pieces. And so when you're building a playbook, you have to understand that you have to deal with all these different types of systems and all of the people and processes and business logic that goes along with it. And the knowledge for a playbook is going to come in from lots of different places, whether it's ISACs, ISAOs, national certs, analysts, vendors. And today and for a long time, most of the things have been on wiki pages, or they're in PDFs or blogs, or they're in a run book that's on a binder on a shelf. And we're currently at the jog phase. We've gone from walking to jogging, or somewhere in that phase with cybersecurity playbooks in Cacao. Now, I mentioned this at the start of the meeting, but one of the things, the tenets that we decided early on that was important was the ability to sign and countersign playbooks. And this is just a diagram of what that would look like. So you could have various bits and pieces, something signed by Apple or Google or Cisco, and then it could be signed by different organizations, and maybe signed by various banks, and then ultimately signed by FSISAC saying, yeah, we have validated this works and it solves Fuzzy Panda or Panda X, and it can be distributed across the ecosystem. And so from a Cacao standpoint, there are the playbook metadata, and then there's the workflow or the actual steps that are part of it. And those steps can contain commands, or they can contain, references to other playbooks. So you can build playbooks in very compartmentalized type ways. So you can have a whole bunch of playbooks and then call a separate playbook. And then you have this concept of agents and targets. And agents are the things that actually run the commands, and targets are the things they go against. A lot of times you're only ever going to have an agent, and you're just going to define the targeting stuff in a variable. But like in attack simulation scenarios, you're going to want to use agents and targets, because you're going to send something to like a Caldera system, and that Caldera system is then going to simulate an attack against something. And then one of the things that we did in Cacao is made it so that the actual definitions for things like the agents, targets, data markings, extensions could be encapsulated in the playbook itself, so that you could send it as, kind of like a sticks bundle, but where it was completely self-contained, because some operational systems can't make calls out to get data. So they have to get everything all at once. There are several types of playbooks in Cacao: attack simulation, detection, engagement, investigation, mitigation and remediation, also prevention and notification. And so there's a lot of things that you can do with Cacao and playbooks. You can define these. We've worked with MITRE, and they've come up with MITRE and DHS has submitted a lot of content about giving extra content or context to some of these. And so that's in the 2.0 version. And then from a step type, these are the various types of steps you can do. There's explicit start and end steps, and that's because it comes from BPMN, where you actually define these things. And so you have really, there's no implicit, start or and end to a playbook. There's very explicit starts and ends. And then actions is where most things get done. A playbook action is when you're going to call another playbook. And parallel, then you have the different types of condition and logic steps, whether they're parallel, if condition, while condition, switch condition. And then as an example, this is one of the ones that we put together. This is in a very BPMN style look, but it's all based on Cacao objects and object types. And so you can render the, obviously there's some people that are working on visualizations, but you could definitely document your Cacao playbook in a traditional diagram view in like a BPM type look. We did set up a GitHub repo to collect examples of Cacao playbooks. We have one in there now. We have a bunch of others that we're trying to get cleaned up and get converted into the 2.0 version that we made for earlier versions of Cacao. And then those will get here. So you'll have a library of different things so you can see examples of how everything works. And so with that, I'm going to turn it over to Vaughn, and he can talk about what they're doing at Sidearm.
Thanks, Brett. So I was going to run through just some things we've learned about Cacao and implementing it at Sidearm. So just for a bit of background, this is an idea that we latched onto maybe a couple of years ago. I think when Cacao was fairly early, we saw it out there and decided this would be actually a very useful addition to our case management platform. And we've actually managed to get the support of the Australian federal government to work with us as a design partner on this. So this will, it's actually very close to release, and we will be using this in a government context. Also wanted to give a quick shout out to Vasilios and Mateos from the University of Oslo for putting together the Cacao JSON schema. That's also been very useful in authoring playbooks. So our approach really has been that you can't automate cybersecurity processes entirely. When you're looking at a cybersecurity incident response, there's often administrative steps, and there is a high variability depending on situations, and a very low tolerance for errors. So you don't want to automate too much. And this was actually a view expressed last week at the Gartner Summit by one of the analysts there, that rather than automate processes, we're looking at automating activities within those processes. So for that reason, our platform is based on the idea of case management for cyber operations, and we're looking to automate parts of that workflow when you're doing a response to a particular type of incident. So for us, the playbooks represent these processes at a more holistic level, and they could involve things like, contacting a regulator, counseling users, scheduling people for retraining, what have you. But there's always a human in the loop for anything that's risky, or frankly, for anything we can't automate, because we can't automate everything right from the get-go. So the idea is we start with the goal of defining a process, and the process at the very beginning could be entirely manual. And then we might start to automate some of the steps in that process, some of those activities, so that it becomes a hybrid playbook. And then eventually, if the playbook is deterministic enough, if we're confident that it's going to follow the same process every single time we run it, it could become a fully automated playbook. And it might be for specific situations, you can do that fully automated approach. So a few of the challenges that we've run into in addressing this. First of all, how do we reuse the steps? There's often steps in a Cacao playbook that you want to share between different playbooks. If you can envisage a drag and drop, composition type interface, is there the notion of a standalone step? And I think that's something where, I guess, making up as we go along, but yeah, this idea to compose playbooks of components. Oh yeah, please. Oh, do you want to come up here so I can? Yeah.
So I can answer that. So steps have unique UUIDs, and so they can actually exist on their own. And so you could actually store them in a library and then just reuse them.
Cool. And that is exactly the approach we've taken. I'm not sure that it's called out explicitly in the spec as a thing you're allowed to or supposed to do. The other call out here is there is a difference, we believe, between what is shareable between organizations or through ISACs or government recommendations versus what is executable right now. So if I was to take a shareable playbook from another organization and it was a completely fully automated executable playbook, when I load it onto my system, if I've got a different brand of equipment that doesn't respond to the same set of commands, if my IT estate is organized differently, I might find that I can't follow the exact same steps. I might have to customize some of the automation steps. And in fact, organizations may not want to share a complete playbook with all of the details of the equipment they're using, and because it might be divulging very sensitive information. So we believe there needs to be some way to take a Cacao playbook and automatically strip away any identification information that's specific to an organization, so that the generic process, along with the steps that can be automated, are shared, but without sharing all of the specific details of how the source organization plans to do this. Some other issues we've run into is when you take a Cacao playbook and attempt to run it in an environment, there is some state management that needs to occur. And you need to also be able to handle re-entrant workflows if you're going to implement while loops. So that's just a few of the pragmatic challenges that exist. Also on the security side, something else that we've given a lot of thought to is the security of the playbooks. So anytime you automate something, there's always a threat model where an attacker could leverage that automation against you. And in particular, some things that we need to be very careful of are command injection via variables. And I think actually OpenC2 is a really nice mediation layer here, because rather than running a bash command or an SSH command with variables inserted, you're actually abstracting that and sending that to an actuator, which will hopefully validate its input. Sorry, question. Yeah. If you're speaking.
May I ask a question? It's Larry Feldman. My question is, I admire everything what Cacao is doing. I have just one question: how it's going to be implemented in specific companies or organizations? So they have special conditions, they have special configurations, they have special procedures. One is for financial services, another for real-time control organizations. So how they need to adjust Kakao? Let's say we already have playbooks or templates for playbooks. How you think it's gonna be implemented for real using?
Yeah, good question. And that's exactly the space that we're leaning into at Sidearm is trying to figure out how we can design playbooks that will be useful to a particular environment, but then also shareable with other similar organizations. And I think how you respond to an incident at a very high level is perhaps generic enough to be shared. How you respond at a very low down technical level, maybe this is where you have steps in your high level workflow that are actually executing your own custom playbooks to do tasks that are specific to your IT configuration or OT configuration. Hopefully that is a useful answer. Oh, I think Brett's got something to add.
Yeah, so originally we had this concept of operational automated playbook and this concept of a template. But what we found in practice is nearly all playbooks will effectively be templates when you share them, because there's going to be, you know, information that is specific to your organization that you're going to either filter out or you're going to put in, you know, you're going to redact it. And so when it goes out, then, you know, the tooling would need to be able to recognize that redacted data and be able to have you prompt the user and say, okay, now you need to fill this and you need to finish fleshing out that playbook for your environment. And so if you think about it like the critical controls that come out of CIS, those could be operationalized in a playbook, but you're going to have to go in through your tool like yours and go in and add the various specific bits and pieces and the data to make it work for you.
Yeah, thanks, Brett. And that's a set of assumptions we're operating under currently. And I'd say that there's two layers as well. And this actually speaks to my last point on this slide about tradecraft confidentiality. So on the one hand, we may not want to share specific data about the configuration of our IT estate through inference by sharing a playbook. The other piece is you're probably not going to see big repositories of playbooks or real operational playbooks on the internet because, of course, threat actors use the internet too. And we really don't want them to be able to anticipate what we're going to do, especially if there are automated steps. If you just think about the potential for denial of service, people could play absolute havoc if they knew what your automated playbook was going to do in reaction to some type of attack.
Through the chat that he'll demonstrate part of this.
Oh, cool.
Right. And a key point to that is we also heard those very same arguments when we were first doing sticks and taxi with threat intelligence, that nobody would share it because nobody would want to share what they learned. But we've since seen that people are actually more willing to, and the Office of General Counsels at various companies are realizing there's great value in this trust group kind of sharing. And so that is where I see Kakao playbooks. You know, yes, there might be some that are publicly available, like I mentioned, the CIS critical controls, or like something from NCSC out of the UK or something out of Australia, where you say, okay, here are things that you should be doing. But then you would take it and tweak it for your environment. So,
yes, certainly at a high level, I think the high level processes are not really a big secret. So, all right, just one more slide from me. A new development. We released some open source yesterday. Basically, we have this goal that we've been executing on for some time now to build software that will execute Kakao playbooks integrated into our case management system, obviously. The big problem we had was there was no repository with a whole lot of Kakao examples. That there were a few floating around, but you know, fairly limited. I stumbled across this. So I'm actually the CEO of the company, but also I do a lot of tech recon. So I had a chance to play around with some playbooks in BPMN format that were put forward by CISA. And I thought, well, wouldn't it be cool if we could convert all of these from BPMN into Kakao? So I had a crack at doing that. I've released that source code yesterday, so you can go to that URL and find it. And now we have a whole lot of Kakao examples. It didn't work perfectly. There are some control structures that we can't handle. In particular, the BPMN gateways are problematic because Kakao tends to favor more procedural language constructs, whereas BPMN has this more abstract way of doing control logic. And we still need to be able to add maybe some OpenC2 type templates for some of the automated steps. At the moment, they're sort of notionally automated, but they don't really have any way to do that. So yeah, it is open source. We would welcome contributions to this, and yeah, we'll see how much uptake we get. That's all I had. Yeah, if you go to that first URL there, the CSERGov repository, there are 81 examples organized in directories.
Yeah, and there's also a lot of work that John Hopkins APL did on their IACD work.
Charlie has his hand up.
Yeah. Hi, everybody. I'm Charlie Frick. I'm the guy that wrote those 81 playbooks. And they're based off all the use cases that we did under the IACD project. But happy to, if ever needed, happy to answer any questions about them. And
Thank-
glad,
thanks,
glad, and glad,
Can you paste this
I'm grateful someone
URL
used it.
in the chat.
Thank you, Charles. I've become a big fan of your work through doing this. And oh, sorry, I think I'm getting echo there. I've become
Can
a
you
big
paste
fan of
this
your work through doing
URLs in the
this. So
chat?
thank you. Oh, sorry. Are you speaking? I've got weird-
Yeah, I was asking if you can paste these URLs in the chat.
Yeah, I'll
I-
paste those in the CASP channel, the CASP channel. Yeah, I was just saying, Charles, thank you for putting those playbooks together. Yeah, big fan of your work, obviously, and you know, hopefully the cacao examples are useful to someone as well.
Very excited about it. And thank you for validating the month of December 2020 that I had to spend writing them.
Awesome, thanks.
You guys have, like, go ahead and say we'll publish the slides and all that.
Yeah, so we'll publish the slides and all the links after this meeting. So yeah, and John Hopkins APL, they've done a lot of work on, you know, various stuff and a lot of examples and things. So but now that we have cacao, it'll be great to be able to start to model this and then get all the diagrams and stuff like that. And as I mentioned, we do have the GitHub repository where we want to start collecting all of these. So if you have some, do pull requests and we'll just pull them in. And I've started working on a cacao validator, a standalone Go code that you can actually run, and it'll just validate to make sure everything's right. So, and it does quite a bit already. So, all right. Yeah, VAS has some stuff now.
Did you want to do a demo? Live? Do it after that.
Yeah, I mean, we can. I've shared a link in the CASP channel to a demo stack that we set up. So if anyone wants, I mean, I could do a demo on here, but if anyone wants, yeah, maybe we'll do that after. I don't want to take up too much time.
All right.
Well, we still have time. We have time. So.
Yeah.
All right.
Yeah.
Let's go and then.
And it looks like Mateus from Oslo has put in a link in the chat for doing some cacao and BPMN modeling stuff. So we'll try to. Jane? Can we capture the chat log at some point before we close out the meeting? All right, Vasilios, are you on? Are you ready?
Yes. Can you confirm that you can hear me? Can you hear
We
me?
hear you loud and clear.
Just one
Okay,
sec on
great.
our end. We got to get the microphone next to a computer.
So is it fine now?
Yes.
Okay, great. So yeah, good evening from Oslo. So basically, next slide, please. And I don't have much to say. I think that Johan and Brett covered quite many things about cacao. I would just like to remind to people that even though that this is a cybersecurity automation workshop, that cacao itself, even though that is an almost to be standard that describes a schema, a machine readable schema, it can be considered also a path to automation. So it means that it has multiple use cases. You don't need to focus only on on having orchestrators and executing things, but it can just be a way to just start creating your processes and documenting them into a machine readable format. And this allows you to have something that is tailorable, modifiable, create a knowledge base of something, and have a knowledge management system that can identify playbooks. Similarly, we discussed a little also about how cacao playbooks can integrate and why should integrate with cyber threat intelligence. So let's say that we have an indicator alerting about something, possibly you can get a recommended course of action to perform something automatically or manually, doesn't matter. For that reason, we have developed a couple of extensions. Here I'm just describing the use case of Sticks 2.1, but we also have an extension, an object template for MISP, and they have one-to-one mapping. This is work in progress, so it means that we are going to update them because we have received a lot of feedback, but we didn't have enough capacity to update extensions. But I'm not going to say too much here. The screenshot that you can see is basically I retrieved it from Charles' presentation that he's going to give later today that describes a series of behaviors that at some point they connect with a course of action and the playbook. And there this extension is used so we can accommodate the playbook into a Sticks feed. Next slide, please. So having said that, what happens basically is that a Cacao JSON playbook is encoded within a Sticks feed. We have our own validation schemas that we have published. They're publicly available, so they are open. They do retrieve quite many pull requests with improvements, and they follow. I think we have captured even the latest specification that has not been officially published, but it's a committee specification draft that has been approved. So we have validation schemas for version 2.0. And parsing Cacao playbook, we have created basically a software stack that allows us to generate, modify, and visualize Cacao playbooks. This is a quite big tool, but for the purpose of this presentation and being able to present something to you, I had to, get permission. So we removed multiple components from this tool. So I can demonstrate you just the symbol editor and not what happens with the rest of the tool. From information sharing to orchestration, etc., etc., etc. And if we have time, I can just share my screen and I can show you the playbook. So this is basically the playbook that Charles shared with me yesterday. We imported it into our engine, and then we saw that it was version 1.0, and we have our own elevator, and we transform it to Cacao 2.0. And then I send it back to him for the purpose of interoperability and demonstrating our use cases. And I'll share my screen. Just give me a second, so I can just show you a very tiny demo. And can you confirm that you can see my screen now?
Yes, we see it.
Okay, perfect. So, well, this is a symbol editor for Cacao playbooks, and it can do almost everything that you would like to do. Basically, Brett earlier described the available constructs in Cacao, and I won't start now creating playbooks, but basically it works like BPMN. We have kept the same way of doing things. You can see here the playbook metadata, and to make the long story short, I'm going just to import the playbook that Charles sent me, and he's going to demonstrate later today. And this is the playbook that he shared with me. Right, and basically you can navigate, you can do whatever you like. So the name of this playbook is current intermediate with a specific process name here. We could basically manipulate this one, and we can change it to whatever we like just to make it look better. And we can see a series of action steps and an end step, and we can do a bunch of things, right? So we could extend the way we like, and based on our needs and use cases with other stuff, right? So that would be it. Our validator, for example, here has identified that there are issues, so we can see exactly based on the validation schemas what is missing. So we have not populated the agents as Brett described it as a construct earlier. Yeah, that would be from our side, and I'm not sure how long we are going to stay, but if you have Cacao playbooks that you want us to generate, maybe we could stay for a while and start populating them. Yeah. So
Vaz, this is
and
Duncan
possible.
with a question.
Yeah.
Is this open source, a commercial product? When can we have it?
Yeah, so this is not open source yet because, as I said, it's a software stack. It comes together with many things, but possibly we can get an approval to open source the editor itself, what you see right now, and its latest version. But basically, this tool integrates with an orchestrator. I cannot give details, and also can perform. It can create sharing communities to exchange stuff and integrates with MISP and OpenCTI. That's the most that I can say.
Thank you. Thank you. And I guess we have, if we could pause you for a moment and then let Vaughn do his, and we'll give you 5 minutes and then we'll move on to the next one. For those on the call, give us one moment while we switch computers to which ones to share.
Yeah.
Can you keep an eye on the, what is that area out there called?
What is it? This area?
Bloom, you can
Your
mute
mic's
yourself,
open.
please.
See if delivery person.
Oh, yeah.
All right, I'm going to try. Oh, we have echo. All right, check, check. That's fine. That's not too bad. All right, so we've got a few of the BPMN Cacao playbooks here that I've just converted. Here's a very simple one. It's just a series of steps. You can look at each of these steps and view a description for each of them. And then here's one that's got an if statement in it. The conditional logic obviously can't be generated automatically, but we've done our best to insert a condition in there to make it look like it's got conditional logic. And here is an even more complex one here. So this one is responding to a domain IOC. I think this is from one of the subdirectories. It was from looked like a workshop of some kind. So yeah, you can see that's what it looks like. We've used these curved transitions because it was just hard to automatically lay this out to look pretty. So we wanted to make sure it was clear where lines are intersecting and going under the others. How this looks when it's applied to a case, I'll just create a new case here. Say, what was that? Domain response. So I can go into the playbooks field here, add a playbook, and what was it? Response to domain IOC. Add that in there, and you can see that basically, and this is where I talk about state management. What we have here is the playbook, and you can see that all of these steps are marked blocked. So if I first execute the start step, mark that success. I should stress this is a prototype. It's still very much under heavy development and test. So ideally, the start step would be automatically completed when the playbook is loaded. But now we've got this extract domain from IOC state that's in ready. So I can turn that to in progress. I can add comments to this. If this was a manual step, I can say, extracting.
Nice. I like the
Extracting
integration.
IOC from domain or domain from IOC, you get the idea. Save that. And that comment gets recorded on the case thread, which is, on the other tab. So I won't show that. When that's completed, I mark that success. And then we'll move on to the next stage. This becomes unblocked and so on. You can continue down. And the idea is we're using, or rather borrowing an idea from computer science called the Blackboard model. And the idea is that rather than have an orchestrator that runs everything automatically and occasionally reaches out to a user to ask for input, what we're doing is the case management system actually maintains all of the state in the same central relational databases where we keep all of our other data. And the orchestration basically is a service principal. So it's just like any other user on the platform, except that it knows when there is a state that's now already unblocked that it can address, or rather I should say a step, and it will actually go and execute the command in that step and then mark that step done and populate the appropriate output variables. So the idea is you can mix human and machine control in this hybrid manner. And the machine acts just like it's a virtual SOC analyst, really. Yeah, so that was all I wanted to show.
That's really neat. That's really cool.
Yeah, for those who are in the CASP channel, I've posted a link in there, and you can get to this stack. And then if you want credentials to log in and play with it for yourself, yeah, feel free. I set this stack up specifically for OCA. It's got OCA branding on it, as you can see. So feel free to jump in and have a go.
Okay. And then over the next 6 to 12 months, we're going to start seeing a lot more like proliferation in the market, and people start using these platforms, and taking a platform like Sidearm and integrating it with their tip and being able to do some really cool stuff. So
Thank you. So it's now 2 o'clock and time for the TAC TC, and Ryan, you are up. I can click through if you want to talk, or you can screen share, whichever you prefer.
I'll just let you click through and I'll just indicate when to click, and if we have time, I'd like to demonstrate a little bit of this so that it's recognized as not being vaporware. So, but I'll let you manage. I'm remote and not sure about the stability of my connection, so we'll go from here. Okay. So threat actor context ontology. Vasilios and myself co-chair this technical committee. And we've got repositories that you see that hold the content of our work, and you'll be able to pull the latest and greatest development work that we've been doing if you'll just go ahead and click to the next slide. So the TAC TC was formed in the latter part of 2019, community driven, and the desire of the Threat Actor Technical Committee was to move from an exchange format that Styx had provided for us and move to a full-fledged semantic graph or analytic format. So we're going to cover a little bit about how we accomplished that first step, or in the process of accomplishing that first step. Then we're going to talk a little bit about the mechanics of actually moving from STIX 2.1 JSON into a STIX knowledge graph. So we wanted to be able to do the graph theoretics, the graph analytics on STIX shared threat intelligence. So we'll talk a little bit about that transition process. Why would we want to do this? It's because in the knowledge graph environment, we have access to executing formal logic. So based off of facts that had been provided via sharing of STIX formatted data and running description logics reasoners, we can imply new facts from the existing old facts. And beyond that, we're going to show you how that inferencing can actually be applied in a graph setting to automatically classify threat actors according to the enterprise's definitions, extensions of what threat actors are to them according to their definition. So it kind of walks you through what we'll be doing in this few short, brief slides that we've got to present. So next slide, if you will. So this is a graphical representation of that verbiage that I just gave you. So if we have, say, the STIX 2.1 JSON from the MITRE attack courses of action, or the CVEs from National Vulnerability Database, or even valid JSON STIX 2.1 from any source that's providing valid STIX 2.1 JSON, whether that be MISP or Palo Alto's Unit 42 or Cacao playbooks, anybody that's producing valid JSON in STIX 2.1 format, we want to be able to take that data and actually convert that exchange language data into a knowledge graph. So that's what the threat actor context ontology allows us to do. So we're going from exchange to analysis and reasoning to generate new facts, which could be supplied as, again, STIX output. So this is not just interoperability, which is what a STIX format provides us, interoperability between systems. This gives us semantic interoperability. The meaning of that data can be shared back and forth. Why would we want to do this? The actual knowledge that your security analyst holds today is extensive. These guys are brilliant individuals and intuitive individuals. And what we want to do is to be able to take a fraction of the knowledge that they have and embed it in the platform, in the ontology that we have. And so that's an advantage that an ontological approach has. It's not only capturing the data, it's capturing the logic that's associated with that data. Okay, next.
Wait, what did you say?
I said if we can go to the next slide.
Yeah, no, there was a question in the room too.
Oh, great.
Oh, this.
Okay, I'm not hearing the question.
No,
So
we're ready to go.
I'll address here. So what we're doing is we took the STIX version 2.1 standard and we created an ontology that represented that standard as closely and as rigorously as we possibly could. So the STIX 2.1 standard is, yeah, if we go back for just a second, you'll see that the STIX 2.1 standard is more of an object property graph representation in that exchange format. But an ontological representation has a hierarchical capability. So not meant to be an eye chart here, but you'll see that in this tree structure over here in representing the ontology, you'll see that there's a STIX object, which is subclassed by a STIX domain object, which is a listing of all of the STIX domain objects, including a STIX threat actor. And we've actually gone with an extension from Intel Corporation and their threat agent library, which provides us a subclassing of the STIX definition of threat actors. So there's a very much a hierarchical structure to the ontology versus what the STIX specification gives us. And there's an accounting of the relationships between these objects that's represented in a different fashion than the STIX specification itself. But again, what we've done is just really given it a different format so that the exchange format is now capable of a graph analytic structure. So we've created software that allows us to do this conversion. Okay, next slide now.
I have a question.
Yes, go ahead.
But you said in the previous slide that if anyone produce a schema using the STIX 2.1 representation, you can use that data and then construct the knowledge graph. So and then now you showing us a STIX object. I want to know if the information that contains the knowledge graph is those information reflected in this STIX objects that you're just showing right now.
I think I understand the question, and I will say this, that the representation of the STIX object that's provided to us in the JSON 2.1 format, and it is translated then into an RDF graph, into the semantic graph form, does carry all of the associated information with it that came from the STIX representation. But we can add significantly more context around that object because of the additional knowledge that's embedded in the ontology or the ontologies that govern that graph. So all of the information comes from the STIX 2.1 JSON and goes into the graph, but there is a lossy exchange if we go from the graph back into STIX, because the STIX format isn't capable of representing all of the inferences that can come out of the reasoning engine of the graph, unless we, as this technology continues to mature, unless we can generate the STIX extensions to add to the original specification. Does that answer your question, or did I misinterpret the question?
No, that's fine. Yeah, it does answer the question. Thank you.
Yeah, and so if we have time at the end, I'll show you that we do have the software to, in this case, what you're seeing here is the JSON representation for APT1 example, that came out of Palo Alto's Unit 42, and we've translated that into RDF format. In this case, it's in the turtle format. Okay, next. this is highlighting that that extension that we're talking about. And here you again can see that we've got a sticks object as kind of the base object. You'll see that the basic and well-recognized types of sticks objects. We have the sticks domain objects. We have the observable objects. We have the relationship objects. We've represented all of the sticks, SDOs, SROs, SCOs, metadata objects. And in this case, this example I'm showing here is we're extending the definition of what a sticks threat actor is with the definition from Intel Corp about what, in this particular case, I've highlighted the logic behind recognizing a competitor. According to the threat agent library from Intel, a competitor is a sticks threat actor that's characterized by having very adept skills, by having a business advantage outcome or a technology advantage outcome, is characterized by being clandestine or by having external access or minor extra legal limits. These are the things that are defined by Intel about the kind of defining characteristics that a sticks threat actor would have in order to be classified as a competitor. And they have done this for, many different kinds of threat actors, anarchists, civil analysts, competitors, corrupt government officials, data miners, legal adversaries, mobsters, terrorists. They provided definitions in their threat agent library for these very specialized kinds of threat actors. And they provided the logic that allows us to automatically do this classification with a description logics reasoner. If you'll go ahead to the next slide. So here's the case where I'm just showing that the sticks data that came in defined a particular threat actor in the report. And according to that report and the observables that allowed them to make these assertions about that threat actor, when we run a reasoner, it is automatically referenced because of the embedded knowledge within that threat agent library. It was able to recognize that threat actor as that specialized information of being a competitor. So based off of the subject matter expertise, the threat analyst knowledge that was embedded into the ontology that extended the sticks ontology, a description logics reasoner was able to automate the classification of that particular threat actor as a competitor according to the definition that they provided, the extension they provided. Do we have any questions? Okay, I will, if it's okay, I'm going to share my screen.
We did have a question and we were double muted because of the echoes. Brett, go ahead.
So I think it's really great that you're doing this and that you're putting these things together. I just wanted to give a clarifying statement that threat actor library stuff from Intel was not used in whole into the sticks technical committee for a couple of reasons. One, it was deemed as being too exhaustive for what the technical committee wanted for the first couple of versions of it. And then there was a little bit of a licensing issue and concern that the Intel work would continue to evolve outside of sticks, and then you could get into some discrepancies. So I am glad you're doing this, but that is the history and that is the reason why it wasn't used
incomplete is the vast majority of the TC said that it wasn't appropriate at this time,
All
but
right.
so.
And let's not get into
No, I
group decision making now. That's for the CTITC to decide and for the tax TC to decide on their own. We're just to point them out. Dave Kemp also has his hand up. Dave.
Sure.
Yeah. You classified sticks as the exchange mechanism, and the ontology obviously is an ontology. They are loosely coupled, and Brett's point is great. You can capture all of the information you need in sticks without requiring sticks exchange messages to contain ontology data. So for example, you can, if you don't use the threat actor library, the Intel information in the stick standard itself, you're not losing anything because the ontology can do the mapping. It's a value-added process. You don't have to change the stick standard in order to do this. Is that correct?
Oh, absolutely correct. Yes, that's a really good point. That we've created the best representation we can of sticks specification in a sticks ontology, and then in a separate activity. So that means that we've tried to hold as close as we can. We provided an embodiment of the sticks specification in an ontological form as tightly as we can. Then on top of that, we've added additional logic, additional definitions to allow us to do things such as express, as Intel has done here, additional information on top of sticks. So it's an additive situation. It's one building on top of the foundation of the other. Okay, so I am going to share.
I will stop sharing so that you can. Where's the button?
Okay, I believe that I am sharing. So let me get to. So I just want to show you that this is probably going to be quite an eye chart for you, but you'll see again that the ontology has a sticks object that's defined, and then you'll recognize the sticks cyber observable, the sticks domain object, sticks meta object, sticks relationship objects. But it's hierarchical now in nature, and here I've expanded the sticks domain object to expose the attack patterns, groupings, indicators, malware, all of the SDOs that you're used to looking at. Here we've actually defined a threat actor, and you'll note that I've actually created a JSON document and imported a JSON document about a fictitious threat actor, Ryan. The only thing we know about this is in the document is that it's defined as a sticks threat actor, and we have from the sticks definition associated some properties with that. In other words, it has some threat actor types that have been associated, some primary motivations, a secondary motivation. These are defined in the actual sticks ontology based off of the sticks specification. But we've also got some assertions here based off of observations according to the threat agent library, that these characteristics are associated, these defining characteristics are associated with that particular threat actor. So this is the data that came in via the JSON document and assertions from those sources. The thing that's important to recognize that if I actually run the description logics reasoner over this, from these old facts, these asserted facts, and that reasoning, that logic that's represented, it's recognized as being a competitor according to the definitions of what Intel subclasses a threat actor as. I also wanted to show you that all of this work, including Vasilios's and Mateos's rendition of some security playbooks, are in the repository, the attack ontology repository, including the Styx OWL representation. So not the Styx specification, but the Styx OWL, the Styx ontology specification, the ontology for the extensions to the Styx ontology, with the ontology that is extended on TAC representing threat agent context, as well as the Intel threat agent library ontology, which builds on TAC, which builds on Styx. We've also included the directory of utilities for the things that I'm about to show you here. So the software, the sweat equity that we put into this, the software we put into it, you're getting an ontological representation of the specification. And then there's also some utilities to do, I won't call it an elevator, but it is a conversion. So for this particular right-hand window here, this console, you can see that I'm executing a piece of code that actually translates the APT1 JSON document and actually outputs the turtle or the RDF representation, so that I'm not in. So that the output of what you just saw happen takes the APT1 JSON representation and turns it into an APT1 RDF representation, or an actual graph form. So we can take these graph forms and put them into platforms such as I tend to use and like the Stardog platform. So here is that same file that we were looking at and reasoning over. Here's that threat actor. It's now recognized as being an attack adversary. It's a Styx domain object. It's a threat actor, and it basically a Styx object. And all of the other nodes in here are indicating that it's got these defining attributes. So we have a graph rendition of that JSON representation. The point being here is that we can run, now that we have this in graph form, we can run Sparkle queries against it. In this particular case, I've said, hey, I would like to see all of the triples in the triple store here that are associated with that threat actor. And so, and this is with the reasoning on, as I've done it here. Let's run it again. Here's the asserted facts. And if we turn on the reasoner, then we get not only those original asserted facts, but we get an extended list of facts.
So 2-minute warning, Ryan, and I have a question when is appropriate.
It is appropriate. I am done.
I have to play with the echoes in the room here. Sorry, hold one sec. So the TAC tools, so there's sort of like 3 pieces to what you just showed. There were classic ontological tools sort of near the end. You were just using regular, anybody can use that does ontology stuff tools. There was the data you put in it, which is, the data from APT1 or whatever that you get. And then there was some TAC definition information and then some tools that converted it. So the TAC definition information stuff, I assume, is in the TAC repo somewhere. I'll admit I'm not familiar enough with them to know what's where. Are the tools you use to do that also in there? Are they open source, or are those particular company, or sometimes hard to tell the products from the tools and the open source tools, the various stuff we're looking at today? What part of that is available if I wanted to do it?
Okay, great. So the TAC ontology, so that the sticks ontology, the TAC ontology, and the TAL ontology, all of those are in the repository. So you have access to those. The tools that I was using was, one, you were looking at the ontology in a tool from Stanford, the Protege. It's just an ontology editor. It is open source. It's freely available. The conversion software is Sparkle anything. So it allows me to run Sparkle queries and Sparkle constructs against the JSON. So we provide a Sparkle query that can be run by the Sparkle anything, which is an open source and available on GitHub, conversion of the Sticks 2.1 JSON into the RDF graph. So that's the second tool that we showed. And then there are multiple open source graphs, as well as versions of graphs provided by some commercial providers. I tend to use, I like Stardog. They do have a free version. But that was there's Jenna Fusecki, another endpoint. I guess that is something I didn't mention, but we're trying to go from the sticks specification and data that's specified in sticks and get it available in Sparkle endpoints. And if it's and I particularly believe that there's a strong strength in having a Sparkle endpoint that will allow us to do that description logics reasoning, so that you're not you can actually infer new facts. That's the long-winded answer. There was Protege, open source, Sparkle anything, open source, and there are multiple open source triple stores available. We did not provide that information on the we will provide the information, but we don't supply the actual open source code. You'd pull those from the separate repositories yourself.
Thank you. Any other questions for Ryan before we break? Not seeing any,
Okay.
not seeing any on the web. Sorry, I'm spending all my time as an audio engineer here. So with that, we will take a 10-minute break and reconvene at 2:44, say. All right, all, we are reconvening. We have a few more people in the room than we had earlier, so it's a little bit like herding cats to get them to sit down and shut up. That's to you, Chris.
As it was in the beginning, is now, and ever shall be.
Yep. Oop, I went the wrong way. All right, next up is Charlie from the Applied Physics Lab talking about IOB. Do you want me to click through your slides and you'll talk?
Yes, that'll be great, Duncan. And then I'll tell you when I'd like to pause and I'll demo some stuff towards the end of the deck. But we'll just start right now and go through the slides. So next slide, please. Next one. All righty. So everybody, my name's Charlie Frick. As Duncan said, I'm from Johns Hopkins Applied Physics Lab. I also chair the OCA's Indicator of Behavior subproject. And I will say just two quick thank yous out there to Vasilios for helping me with the cacao content for this talk, and also to David Kemp for providing the Amazon EC2 instance that I'll be using in the demo. But I wanted to take a moment and explain what indicators of behavior are, and then show you some of the ways that we were able to integrate the various standardized and open source tools that this community has given us to take advantage of them. If we can go back 2 slides, please. Back a little bit more, please. A little bit more, please. You kind of jumped ahead a few. We're going the wrong way.
My ebook reader goes crazy like that sometimes.
I was trying to adjust the volume so we didn't have this weird echo in the room, which we still have. And instead I ended up moving the slides.
Okay. I thought you were just telling me to get off the stage, Duncan. It's okay. All right. Motivation for the project. Forward one more, please. Okay. So I think we're all in agreement in this community that, we're here to help people use their threat intelligence better. And STIX has been a game changer in standardizing that. And we wanted to look at how we share additional context. And what we found is MITRE, attack and defend have been great languages, but when we really want to share to automation, we want something a little bit more specific, but still repeatable. And that led us to look for something that could be a little bit more general than an indicator of compromise, and a little bit more specific than the data that we're finding inside attack and defend. Next slide, please. So this overall concept was to utilize extensions to STIX to share a repeatable set of observed adversary behaviors and do that. So I do that simple example there of, I want to share not just behaviors, but ways to detect them and ways to correlate those detections to see when there's common values in between various alert fields. Because I can take a sequence of 4 behaviors: a machine opening a potentially suspicious email, a machine running PowerShell for the first time, a machine having a registry modification, and a system level process sending some suspicious traffic. Any one of those behaviors by themselves normally doesn't have an analytic shared widely with it, because those analytics have a high false positive rate. But if we think about those analytics to be processed by automation and also share how we correlate it, if I can identify that sequence of behaviors occurring from a specific machine within a certain time window, that sequence most likely is not something good. And so we wanted to see, how could we share this data while still preserving all the other great context from things like attack, and make it better for people, and in our mind, more importantly, automation, to receive those detections and receive the correlation logic, as well as triggers for courses of actions and security playbooks. If we go forward one more. And so I kind of did this visualization to kind of show those light blue blobs would be a couple examples of our behaviors: receiving a fish, downloading a macro, and some abnormal DNS traffic. And we can still follow all the stick structure to include the referenced attack patterns from MITRE ATT&CK and our different cyber observables. But what we also want to be able to share are those detections in the red, represented in the red squares. And we can do those detections in all sorts of formats. Stick shifter is a great one. Sigma also has been very popular for detections. But we also want to be able to correlate that, which is what the pink blob represents. And I'm going to show some detailed examples here to say how we compare things that are in between. For today's demo, we're going to use stick shifter for the detections and Kestrel to correlate. And then once you've correlated and identified a threat, we might want to share suggestions on what to do about it. And that's where the course of action objects can come into play. But thanks to some of the research the Cacao team's been doing, we've looked at how you can embed a playbook inside an object that is related to that course of action, so that you could eventually share this type of knowledge graph. This is more a property graph to be super specific, as opposed to the ontologies that TAC is using. But that's what we wanted to start this project to work on. What would the sticks structure look like to be able to share this type of data? And we wanted that to be able to be executed both manually and through automation. If we step forward one more, please. So that brings us to what we wanted to demonstrate here today of how we could take that kind of high-level IOB concept and bring it a little bit closer to reality by leveraging all of our community's contributions together. And so I'm going to talk a little bit about what we brought, and then I'm going to show it. So if we step forward one more. So thanks to the CTITC and that Amazon EC2 instance, we've been able to stand up a taxi server to share some bundles. This particular example was when I was still configuring it. So this is some of the sample sticks you find inside the Medallion CTI tax server, CTI taxi server, sorry, but we'll show you in a moment, pulling that from the sticks from the taxi server with an IOB bundle. But thank you to Oasis and the CTITC. Next step. Next slide, please. Yep. That for analyzing the data in the sticks bundles, parsing through the raw JSON can be a little bit of a challenge. And we wanted a way to rapidly extract and expand and build off the data inside the bundles. So to leverage that, a lot of our research at the Applied Physics Lab has leveraged converting sticks bundles into Neo4j graph databases. And as part of our support towards the IOB project, we open sourced a small little Python script that you can get from our GitHub that will parse any sticks, should be any sticks two, I think definitely all 2.1 bundles, and any, I believe most 2.0 ones should work fine too. This script will automatically convert that into a Neo4j graph database, both for the expressed sticks relations as well as the inferred relationships from the references fields inside sticks. And this is all available freely under an Apache 2 license. And I'll show you an example in a moment. Next slide, please. And this little graph will dive into an interactive version in a moment, but just showing this is one view of a sticks bundle where we can have our kind of, those blue blobs are behaviors. The light blue is the official MITRE ATT&CK SDOs. And then the red ones having our detection groups. In this example today will be stick shifter. Little purple there because I didn't have time to remember the RGB number for pink, is my correlation and detection group with Kestrel hunt books. Then finally sharing playbooks in Cacao. And I'll do one more slide and then kind of show this more in a live field. And I see the comment there about having a CTI platform. I won't claim that my Neo4j script is as robust as a tip, but it was something we wanted to be able to have that level of investigation capability without having to build full pipelines into multiple tips. But kind of staying in pace with the use cases today, the idea here would be, this would be around the day one period of our scenario. So we talked about the threat intel analysts at Murphy's Law creating and sharing a sticks bundle. We'd be looking at this IOB bundle with the hunts and detections to be included in that data. And then Murphy's Law participating with an ISAC to submit that taxi server to make it shareable. And then your on-deck holdings and other orgs within the community could pull that data. And then for day two, showing folks being able to take that data and rapidly translate it. No, I kind of went through that fast, but I wanted to be able to switch over to showing rather than telling. So if you can stop sharing for a moment, Duncan, I will do a screen share and kind of walk through what some of this can look like. Okay, so right now you should see a big black box with CASP at the prompt. This is
We
a
just see
machine.
big black box. We're not, we literally
see
see
the
a black screen.
Let's see, you're not seeing anything here yet?
I'm seeing the whole screen and the
Okay.
curl command.
Oh, my sharing thing blocked it, sorry.
Alrighty. Can you guys see it in the room there yet, Duncan?
Yes.
Okay, perfect. So right now I had to cheat and use an SSH tunnel, but I have a taxi server on the EC2 instance, and this happens to be a terminal on a machine over here at the Applied Physics Lab. And I'm just going to pull the taxi server real quick, and just show it does work. And we pulled a sticks bundle, and this is the IOB bundle, but rather than, as we can see, and you'll see some kind of funky base 64 encoded strings here, that this is, a little difficult to work with. So now rather than make you guys watch more terminal output, I'll just switch over to a Neo4j view. And we piped that JSON into our processing script and uploaded it into a Neo4j graph database that we're also hosting on that EC2 box. And this is where you can see the entire bundle, including the identity objects. So I have an OCA object for the behaviors and detections and the extensions. And for proper attribution, I included MITRE's identity object as we used their attack pattern objects in our bundle, because I believe in going to the source for sharing MITRE attack data. But I'm going to do a slightly simpler view. So this is going to be just a simpler set of objects. So we can say we have a particular behavior, and a lot of this was inspired from that same Black Hat Kestrel Hunt book, but showing here's an attacker compromising a target and using PowerShell to find local processes and owners. And all of these fields can easily be extracted through code, which is, just a fast way to be able to create some complex queries. And I'll show some of those in a moment that we can feed to additional automation. But along with the PowerShell, we have a detection analytic encoded in here, but I'll show how we can translate that really quickly, as well as a correlation hunt book that then references a course of action to take to remediate that. Once we've identified this sequence of adversary behavior, we're going to want to quarantine and remediate the box, and we'll include a Cacao playbook for doing that. And so one of the reasons I also like Neo4j is I can kind of put together some quick queries to, while I share that data, all base 64 encoded, it's pretty easy once you get the hang of Cypher query language to extract and decode that data on the fly. And this could be happening through some Python scripts or other code that you wanted to develop, so that you can say, hey, our community is sharing this stick shifter search to look for this behavior. And additionally, when I want to correlate that, I can embed the entire Kestrel hunt book. And rather than you guys have to watch me, do more terminal, I queried this out and basically piped this text to a standalone file. And just for full transparency, I loaded that up into a Kestrel Jupyter notebook, and you'll see the Kestrel hunt from that Black Hat 22. I didn't grab the images, but still, it's fairly straightforward for code to rapidly decode and get this level of data out of that shared sticks bundle. And that was what we were kind of focused on for our IOB efforts, so that we could just package the data utilizing our standards to get in the hands of our analysts. And then finally, I don't want to belabor it because the Cacao team did a great visualization earlier, but and it helps if I pull up the right search.
Yeah, but it was your visualization, so you get credit for it too.
But additionally, same sort of idea for embedding. We have the Cacao embedded as base 64, but rapidly pull that out and you can have the whole Cacao playbook in its native JSON format. And then Vasilios did a great demo showing how you can feed that into his visualizer. Now I'll stop sharing for a moment. And if you can bring the slides back up, Duncan. I was kind of speeding through that so we could just make sure to share where you can get access to all of this data and have a little bit of time for questions and get us back on time. So we can step forward. These are just some zoomed in views of those database queries. Go forward again, please. So there's your Kestrel hunt book. We can go forward. And that's Cacao. One more, please. And so the easiest way to get access, first of all, you can go to the OCA project page for IOB. We also have a nice little YouTube animation there to take you through the concept of how we envision people utilizing behavior bundles, as well as that lower link to the IOB GitHub. You can access not just that Python script, but we also have some fairly detailed reference implementations based on APT 37 that also have some pretty extensive technical documentation for all the fields if you'd like to really get into the weeds of all the aspects of the JSON. We include that too for the community. All freely available. Also, as with any OCA project, everybody is freely invited to join us. You can learn how from the GitHub repo information on when to join our meetings. They're the second Tuesday of every month. And we are grateful to have a community like this where we can all build upon each other's things to move forward. With that, I think I have 5 minutes to answer any questions.
You do. You started late and you still have time left. So yes. Any questions from the room? Any questions online? Let's go with the chat. We have weird mic issues.
That's all good. I know I kind of was a speed reader there.
You gotta stand here.
So, and I apologize if this is a question that everyone already knows the answer to, in which case we can follow up online. This is Alan Friedman from CISA. I was very intrigued by sort of your use of being able to describe an automated way of detecting unexpected types of network behavior. Is that something that's been fairly well formalized and discussed, or is that sort of building on mud or whatever Bro became and things like that?
So we use a variety of different sensors, and this is an area, and we definitely can follow up some more. We've been working closely with the CTIS team and capacity building on this research for a few years, and then as IOB was getting started, we began that partnership, both kind of APL, CISA, and the OCA together. But we've been working on this, and a lot of this comes out of the earlier work done through the integrated adaptive cyber defense effort. But we have examples using all sorts of different behavioral analytics. Some has been based on MITRE CAR, some has been Zeek and the RITA framework, as well as a lot of things to utilize Sysmon and some of the ideas being shared over on the OSCF or OCSF project as well.
Great, thank you.
Oh, absolutely. Thank you for the question. And I think Kevin has a question online.
Connects me to a different.
Not so much a question as a
Go ahead. Sounds like someone else had a question.
not so much a question as a hope to flesh out more of the similarities between our use cases and the IOB bundles in future integration efforts, possibly the next one of these.
I would love that. I absolutely would love to do that.
Yeah, we did throw this one together rather hastily. So because CISA gave us so much notice on the S-Panorama and we've been talking about doing this just before it. So we're not quite as well prepared as we could be, which will be really obvious when we get to my next talk. But Kevin or Charlie, did you guys want to say more on the details of that, or how to line them up, or?
Well, I think just as we've seen the talks today, we absolutely, with a little bit more coordination, it would have been pretty easy to get the Cacao with the OpenC2 commands embedded and then feed that shared data straight to the OpenC2 orchestrator. At least I think that's what you were kind of implying, right, Kevin?
Yes, definitely. I think we can get that going pretty shortly after this, but maybe not.
Yeah.
Maybe not between now and when everyone has to head home.
Agreed. But yes, I'm right there with you.
And I'll throw in from my own viewpoint here that that having seen Vaughn's tool today and Vaz's tool today will also making the Cacao playbooks a whole lot easier than has historically at least been my experience. I know Brett can make them in his sleep and just go ahead and create them, but I know in my case I struggle with making them. I can make the little simple graph easy. I can't actually make the JSON to go with it. It takes a really lot of work, and now I just make the graph easy in their tools and hit carriage return and they create the JSON. So I think that will make all our lives easier in doing it too, which is why we do this. Any other questions or comments?
Well, thank you. I think I even wrapped up 1 minute early.
Back to this mic and go back to presenting here. Next up, oh wait, come on up, Brett.
One of the side things that I like about these events is when you have the people that are working on the specs here and you have people that are working on implementations, is getting this feedback loop. So my ploy is, for people that are working on implementations with Cacao, if you find things that are hard or difficult or things you don't understand in the spec or the language, let me know, because we can fix that. So
thanks. Come on up, Chris. We're not going to hear you unless you come up here. So come up here.
your name. Oh, my name is Brett Jordan.
He's the former chair of the CTI and he's the current chair of Cacao.
Thanks.
And for the people on the in the remote audience, that was someone in the room asking someone else in the room who they were. So, but to that point, Brett should have probably identified himself. When he came up, like just like I should probably identify myself as Duncan, but you probably figured that out since the beginning of the day. Any other comments or questions? Hearing none. Move on to PACE, SBOM, and VEX. This is the least prepared talk of everything because I was up till late last night making the at least Blinky I did display earlier today work, even though I couldn't get the Blinky that I have here in the room working, as you all know from earlier. So because of that, I'm not even sure what we're going to see on the next couple slides, but we'll find out. So 3 acronyms, PACE, SBOM, and VEX. We covered them earlier in the day, but to recap them, I will do that anyway. This thing's in the way. Posture Attribute Collection Evaluation is an Open Cybersecurity Alliance project on what it calls security posture attributes, but which SBOM is a major one of them, but basically anything to do with any of those control points we talked about earlier in Cacao, the things that make you go down the different decision trees in a Cacao playbook. That data is what is security posture. For people who attended the recent Gartner conference in DC, one of the major thrusts was their new push in what they call application security posture management, which is basically what we've been talking about in PACE for a while now, as far as taking things like SBOMs and VEXs and using them to derive security posture. Through the links in here for the PACE project itself as part of the Open Security Alliance, through the link in for the GitHub, where there is the particular link I threw in was an example we used at the previous one of these or 2 ago, I don't remember. But one of the use cases we used in a previous cybersecurity automation village back when we called them something else, but on how to basically use the what at the time were called flags and now are called, Alan, help me, what's the VEX, what are flags real name? Status justification. The status justification in for why you're saying in particular a particular CVE does not affect your product, even though you may have the component or may not have the component in it. That was back when we were doing an earlier one of these, a very hot topic over in the software transparency world, and we actually demoed it and used it at that one. And we're going to do that today, but I got behind on everything. And then the next link on there is the sort of, I'll call it public facing, or what we call awareness and adoption link for the PACE project. And it's the securityattributes.org is the public facing website, and the by example subset is where there's a bunch of examples like the one that I just talked about. At the last one of these, we had a lot better turnout because we had a lot more notice for it from the commercial vendors in this space. There are actually a lot more commercial vendors in this space. We do have one of them present in the room, which is fortunate. The demos that go with this are basically the demos we gave back in the OpenC2 Cacao part of the agenda. And to sort of recap real quick, you can't just jump slides in here real easy, can you? I'll just have to do it the hard way. Oop, I went the wrong way. That definitely did not work. Hey, I'm giving away the end already. How do I go backwards? It'll only go forward. There we go. It's been a long day. Where were we were here. Basically, back when we were doing the OpenC2 commands, one of these slides has the request, the SBOM and VEX, and the actual demo that we gave in the, I'll just go back, I'll go all the way back. When we were doing during the OpenC2 part of the demo, we were referring to this part of it, besides doing the commands that made the lights blink and showed you how to turn on the threat hunting and getting the responses back. One of the other ones in there, if you'll recall, was to get the actual SBOM and to get the actual VEX in, which those would be commands that would be sent by the PACE system. And in PowerPoint, I could just put the slide number and hit enter and it'll go right to it. This one I have to, I guess, click all the way through again. I should have copied the slide, sorry. Right, where, yes, and little o or is the O and O or an O? That's the other one. And speaking of software bill of materials, again, shout out to the CISA.gov site. The example used in the slides I just walked all the way back to again was this link here, which is we can actually click on it and go to it. This is again the Twinkly site that we remember. I'll go ahead and do it again, since some of the people weren't here this morning. If I can spell. So as opposed to, I put away my Raspberry Pi, as opposed to my actual piece of hardware, this is so we can do it remote and you can send the command OpenC2 commands to turn the lights on and off. Well, this actual website or the actual Raspberry Pi both have software that they run themselves. And if you just go back and get to it, go to that very device, stored on that device are the actual software bills of materials that go with those devices. And in this particular case, you can have them both for the, I'll say the code I wrote on top or the code underneath it for the Docker image that created it. You could have it in JSON or XML. You can have it in SPDX or CycloneDX. You can have whichever one you want. You can click on one of them just to sort of prove that it exists. The browser can display it. But again, this is just so that you can send those commands. And was Brett mentioned earlier, it's good to sometimes have the standards people in the room when you're doing this. I will have to say that as we developed this particular demo, working with the guys from NSA and HII, we have actually changed the OpenC2 spec on the how to do that, because we get into the actual details of, oh wait, no, that isn't going to work because you have 3 of them. So you got to, this is a list instead of a whatever. So that has been very useful. And we did, like I said, we have actual real user stuff that does this. Get back to the deck. Well, we did that earlier. Plus I had to slip, I had to go all the way back. All right, we can, all right. All right, so. We did do it quickly before, we'll do it quickly again. All right, so there is the digital twin of the piece of hardware. And then, oh, this is a trick though. I gotta go find the other, the OpenC2 test link without going back through 40 slides to get to the link, because I didn't put that link on this slide. Well, we'll do the hand wavy version. If I remembered the big long URL to type in here, there would be a website that would allow me to send OpenC2 commands from one GCP instance to that other GCP instance. And when we send it, which we demoed this morning, we actually sent the command and everybody watching saw the lights change color. I am not going to go back and find that. They'll have to trust me that we did it. We have proof it happened earlier today.
Hey, Duncan, this is Matt. We do have our local version here that we could show, and I have the pub sub app that'll interact with it, sending OpenC2 commands.
Sure, we'll take. Why don't we take a minute and do that? I will stop sharing, and you have the floor.
All right, let me see if I can show mine. All right, you see the Twinkly Maha app on the screen. And I have a pub sub app here locally that I'm going to send a message, an OpenC2 message across the MQTT broker, and then the Twinkly Maha will pick it up. One moment to fire it off. It went off. Oop, you know what? I'm sharing the wrong screen. Give me one more moment here. Nothing like some anticipation.
I'm guessing you're sharing not the one you sent the command to.
Exactly. Yeah, hang on one moment here. I'll share the right screen. Picking the right one now. There we go. I could share the whole thing, couldn't I? Caitlin came up with a great idea. She said, why don't you share the whole screen? That would be smart. There we go. So now you can see the Twinkly Maha on the right, pub sub app on the left. We're going to send a command, do some rainbow work. Woohoo.
Yay.
Now,
Now, did you just send it to the one in GCP or to a local one?
This is a local one, but it can pick up commands from anybody. Dave Kemp was sending some earlier. So it can also take them from anybody that wants to send them and interact with it. And I'm turning it off. I will put the command in the chat if anyone would like to interact with it. And I will also put in what topic we are using.
For those who weren't here in the morning, I put up the test server first, and then I put up this, and the colors started changing before I'd even done it, because other people went onto the test server and started clicking the buttons. But it proved it worked.
Yeah.
All right, so here's the $64 million question, since we're in the SBOM section. If on your local Twinkly Maha, I went to /.wellknown/SBOM, would I see an SBOM?
Oh, we could try it. See what pops up. Never hurts to try, right? And I'm listening to the S fractional command topic.
No, what I'm saying, what I'm saying is on the web, over on the white page. Go replace Twinkly with .well-known/SBOM.
Yeah.
It is the correct use according to NTIA, soon to be CISA documents. Or is it, or did we put it in IETF stuff? I don't remember where we put it. We actually wrote it down. Okay. Actually, Matt, before the word S,
yes,
put .well-known/ where Twinkly is, right there.
Take one.
.-well-known/ tac.
.w, no, .well.
This is the that gives up control of the internet.
No SBOM there. Take the SBM. Now just enter. Aha. You have the placeholder site, but you didn't actually make your SBOM, so Alan can yell at you.
Yeah, Alan, you can yell at me. Sorry.
No problem. No, thanks for doing what you did.
No
Why don't
problem.
you stop and let me take it back because we,
Yep. It was fun interacting with you.
thank you. Let me share again. All right, back to the deck. So we're talking about software bill of materials. We just did the little, well, earlier in the day, we did the demo that was shown on the bottom there of the OpenC2 test machine sends, or anybody who wants to sends the MQTT query command that now this thing is covering up. That either asks for a list of the SBOMs present on the device. When we originally developed all this, we were thinking there'd only be one. We realize now that even a single device can have more than one SBOM on it, both because of the different formats, but also because, as we showed in the example, there's sort of the application layer code and the underlying operating system code. At least that's how this particular one was set up. It could be more. And so you send the query and say, hey, what do you got? You get those answers back, and then you send individual queries for whichever ones of those ones you want. And in what we prepared for the demos earlier today, you can do that for Twinkly Maha, the digital twin we showed, the Blinky Maha, that even though we can't make the lights light on it, we can actually get the, we can't make it the MQTT to work, but if you could, the SBOM is actually there. And then the other thing, which we didn't go over much, is Quad Block Quiz, the game that we made associated with software supply chain. That again, a shout out to, or a call out or request to all of the organizations on that big circle we show of everyone involved, that if you would like your own quote category of quiz questions to go on that game for the next round, I am welcome to add those in. And then finally in my section, as we run out of time, is the vulnerability exploitability exchange, or VEX document that we talked about. That obviously I never finished this slide, but the, again, on that website that we just showed, in fact, I can go back to it. So we can say that these things actually do really exist. People should probably argue it should be on .wellknown/vex, but I didn't happen to do that. Oh, and I did not put it on here. I thought I did have it on there. I guess it's on Quad Block Quiz, which I don't have the link. Oh, I do have the link for over here. Oh, why did it do that? I do not have the link there. So I apologize, but there is actual, for one of the websites, the Quad Block Quiz website, there is a VEX as in CSAF format on that particular link, and I didn't put the link in here. So my apologies, but trust me, it exists. If you ask me afterwards, I'll show it to you. And now it is time to get to the review and next steps. And at least in theory, all of the wranglers for the different sections have been studiously filling out the web pages that we're about to review. I know I'm saying that very facetiously, but we will sort of briefly go through them and audibly summarize it and then fill them out before we do the true next steps. So for this section, we're going to go over each of the projects that we did go over the data for and sort of do a takeaways from each one, see if there are any action items of what we need to do. And then there are a couple slides on what happens next in this august body. So starting out in OpenC2, I can see Dave Kemp filled this out a lot in the intervening. He actually had the most time to do it. He didn't do it, so I don't have high hopes for any of them. But Dave, do you want to do, or any of that crowd want to do a quick recap of what we learned, what we showed, what we should take away?
Gee, that would take some thinking. But fortunately, we've got the video, so we can extract notes from.
Could you speak up a little?
I'm sorry, I had the mic out of the way. Yes, fortunately, we have a video, so we can go back and look at it. But yes, I don't have any cogent thoughts right now about what we want to preserve for posterity.
Well, I mean, I'm gonna throw in, although I'll get the echo shut it off. I think we did, I think this is gonna be true of each of the ones when we get to this. I think we did make really significant progress. We did have multiple organizations, in this case, 4 different organizations with different people's stuff, talking to different people's stuff across several different projects. So I think from a sort of overall, what we're trying to accomplish from a mission viewpoint, we did actually make a lot of progress. One of the points I think we should also make in it is the one I made just a few minutes ago about just the doing of this resulted in changes. We some of the changes, like, yeah, I had to fix a lot of bugs in my code. That's on me. But some of it we have to change. We actually change things in the spec to make them better, either from an interop viewpoint or an easier to implement viewpoint. So I think that that's worth noting also.
Well, at an even higher level, just having this event, even given the short notice, we've been cats with hammering on keyboards, for the past 2 weeks that we hadn't been doing for the past 2 months. So this event and its follow-on events are real catalysts for making progress.
Agree. Any other thoughts or comments before we go to the next one? All righty, Brett, you're up for Cacao.
So I think today we saw several good demos, progress being made, people using Cacao and integrating it. And, we're still in the process of working with getting the OpenC2 pieces and the Kestrel pieces put in and getting some examples there. But the feedback I'm hearing is, while there might be a few little things we should work on in the spec, by and large, the spec is actually working and solving the problems. I've been getting feedback from people at MITRE and other companies that are implementing Cacao that it is actually solving problems and making things usable. So we had a good demo from Vasilios. We had a good demo from Vaughn, some GUI drop and drag tools. So it's really kind of looking, like it's starting to gain some traction.
Thank you. Any comments or questions from remote or the floor? All right, then we'll move on to Ryan. You're up with TAC. Ryan, you still there? Lost some people. All right, well, we'll task him later. Charlie, you're up with IOB.
Okay, well, I was frantically typing into the slides, but it didn't update.
Oh, maybe I need to
So-
maybe I need to refresh.
You could try. Yeah, that worked. Slide 92 is me. Oh, it's going the wrong way. Okay, so yeah, just recapping, that, sharing the STIX compliant bundle for sequences of behaviors, detections, correlations, and response. And that's allowing us to leverage all of our different projects together to combine multiple open capabilities inside a STIX bundle. So demonstrating the use of STIX Shifter, Kestrel, Cacao. As Kevin mentioned earlier, we could easily start incorporating the OpenC2 within the Cacao and utilize Taxi for that machine-to-machine sharing. And just highlighting again, we utilize that Neo4j script to give us a little bit easier way to query and investigate the raw STIX objects. And for more information, please come to the IOB site or feel free to contact me as the IOB subproject chair.
Thank you, Charlie.
And thank you. And thank you, everybody, for today.
Questions or comments for Charlie? Ready? Obviously, I've not typed a thing here since I finished talking 3 minutes ago. So I will go ahead and do that. But again, similar, major focus, the previous one of these was SBOM, so we have a lot of base to go on there. We just didn't pull as much of it together for today as we should have. But we'll, particularly with the increased focus on pace, we will do that for next time.
Hey, Duncan, can I ask a dumb SBOM question real quick?
There is no such thing as a dumb SBOM question.
Just a great question from an inquisitive idiot then. Do you guys give like guides or references to the tools for generating SBOM? I just know from my own Googling around, we've mostly been using like CDXGen and dependency track for building out SBOMs and VEX files, but I wasn't sure if the PACE project kept some sort of listing or repository of some of the various tools to help people with building them.
The PACE project does not, because the US government has done such a wonderful job in doing that already. First of all, there is something called SBOM-orama that is tomorrow at this very campus. That's one of the reasons we're doing this here today, where they'll go over that in even more detail. But if you go to cisa.gov/SBOM, there are various resources there that can help you. One of which is a new FAQ about to come out that the old FAQ also has this answer that basically asks your question and then gives 3 short URL links of where to go to, but also on that major site. And then I'll turn it over to Alan, who can really answer all these questions, to say there's an entire work stream on that that meets weekly. They meet weekly? Yeah. That meets weekly on that very topic and puts out lots of good data. But with that, I'll turn it over to Alan.
So we're now at a level we can break down different types of SBOM tools, very high level. It's generation, management, and consumption. The generation space is quite rich. Probably the best resources for those are both the SPDX website and the CycloneDX website. And as a side note, CISA is working very hard to make sure that those 2 data formats are compatible. They should be, they don't always get along. On the management and consumption side, those are more emerging spaces, which kind of makes sense because until recently, people didn't have piles of SBOM data sitting around. So it'd be kind of weird if someone spent a lot of money on a tool. But there are more that are emerging, both in the startup space. And one of the areas that I'm quite excited about is a lot of the bigger security companies that are already providing vuln management, asset management, EDR types are starting to integrate SBOM into their tools. So short version is, I think in the next 6 to 9 months, we're going to see a lot more out there, both open source and commercial. And on the generation side, it's now sort of devolved into sector specific, right? There's folks that are doing embedded and firmware specific tools, and those are very different than the people who are doing cloud native analysis tools and things like that. Is that helpful?
It is. Thank you so much.
I do not. Yeah, this is probably a bigger group and I'm comfortable having a candid conversation about them. If anyone wants to know more about the specs, they're both good. They're both modern. SPDX just came out with SPDX 3.0. And so I think that's going to be field tested. It's a lot richer than the old one. Both of them have started to really accelerate a large number of features. And you could think of that as good or bad, right? If you want just basic cross-compatible, everyone uses the same basic SBOMs, it's not great. If you want lots of neat little features that maybe aren't universally used, then why not throw lots of features? And so what we're doing is trying to make sure that that core remains that, so no one should care what they get their SBOM in, because you know what machines are good at? Handling well-structured data. It's just JSON.
So on that note, let me point out to Alan and introduce him to Dave Kemp, who was also on the call from the NSA. And Dave, you should probably talk to Alan about his efforts in SPDX and CDX and keeping them common. You have a tool that derives the common understanding of what the information model underneath is, and that's really what you want to keep in sync. And to Alan, to your point, something I didn't mention in my section because it was getting into gory details, but since you brought it up, I will get into those gory details. Since there is no Jaden spec, the tool that we were just talking about with Dave Kemp has for SPDX and Cyclone DX. We went ahead and made one, and we're now actually including it in the OpenC2 SBOM actuator profile, because we got to have something to compare against. And since they never made one, we made one for ourselves. And so hopefully eventually they'll make their own. But in the meantime, you might want to use that because it does do that.
Thank you. And Dave's been yelling at me for many years.
Okay.
I always appreciate it. He's just much smarter than me. The other thing I'll flag as we talk about getting to the deep weeds, DHS S&T has the Silicon Valley Innovation Program, which is a sort of government-focused venture capital model. And they've recently funded 7 startups in the SBOM space. One of the requirements is that those 7 companies all work together on a tool that will ultimately be open source that's meant to be sustainable and a sustainable translator. And so Dave, I'll circle back with you about your work as well. Because again, there should be no obstacle towards handling and doing very basic data processing for these tools. And if you guys come across an obstacle where someone has implemented something that doesn't work as an easy translator, then candidly, this is where I'm going to speak a little more freely, I feel the US government can step in and say, this doesn't work for us, right? We need this and we need this stuff compatible. We did that last summer at the North American Open Source Summit, where we had a little bit of a Helsinki Accords moment. Whether it worked or not, who knows, but we're going to keep trying.
Yeah, and on those note, I'm a strong proponent in the nonprofit world of what's called purpose-driven. And I think both those nonprofits should be working together as opposed to competing. And there's even like academic papers on how to do that. But Chris, were you going to say something too? Let me turn over to Chris Blask.
Yeah, this is Chris Blask. I was just going to add to Alan's statements. Interoperability is key, but one way to think of it is SPDX is mature and stable and on a good path, and Cyclone DX is new and agile and unstable, right? So either of those could be an advantage for you. So whichever one you want to go down, if mature and stable as opposed to agile and innovative, one of those, is the path you want to go that path, and then look back at what Alan was saying. If this is not interoperable, switch. It's got to be compliant. Got to be interoperable.
All right, so it's good this is recorded. I got lots of data to put on my line here. Action items. The only ones I've caught so far are we need to actually, I should add to this that we need to publish these slides. So we will publish these slides. We will update the website with all the information that came from today, move the future Plugfest of today to now be a past Plugfest, and we'll cover the next 2 in a moment. And what I would ask is for everybody who participates in any of that, I should have re-put the wheel at the beginning here again on all the different projects involved. For anybody who involved in any of those projects, please bring this work back to them. Say, hey, we don't need to all work in our own silos. Let's work together some too, and hopefully get some more people involved in doing this. And then we'll need to obviously plan the next events, which are the next 2 items. And then we'll have to get out of here. So why does this thing always be in the way? Wherever I put it, it's where the next slide is. So we do have a 1-hour slot at the next Borderless Cyber. Recall the last one of these events was at the previous Borderless Cyber. The next Borderless Cyber is going to be Cyber Meets Privacy. It's going to be in London, England on September 11th and 12th at the Royal, I forgot the name of the school we're at already, but the Royal Holloway. And the link is, what's that? The link is shown there. So it'll be basically a meetup at it. There's a specific request to sort of go over how do all these standards work together, how do all these groups work together. And it's to get that sort of crowd of people together because there'll be a bunch of privacy people there too. We were talking with some of them about all their problems, and they're saying they're so unique because they have all these problems. We're saying, no, we have all those exact same problems. So we just gotta get together. And yes, people are starting to show up for the next room, so we will get out of here quick. So besides that 1 hour meetup that we're going to have there are also the papers. I don't remember if the CFP is still open or not, but they're certainly not all selected yet. But there are some relevant presentations to the work of this group that have been submitted. So hopefully those will get accepted and there'll be some talks there as well. And we would ask other people to do that at other conferences. And then the next, I'll call it major village. This is sort of, I'll call it a minor village. We threw it together really quick and we didn't have a whole lot of time even, while we were here. We had basically half a day. There is hopefully to be planned a 2-day one of these events sometime in the first quarter of 2024. It'll probably be in either New Jersey or DC, and the host is who gets to pick that. But if people have a preference to one or the other, the host would like to know that. The host may or may not be the same one that hosted a previous one of these at their nice office in DC. I'll go ahead and say it. I mean, AT&T is in negotiation. AT&T is in negotiation to host the next one. They can't commit to doing it yet, but they're in the process of potentially hosting one. And they have been very vocal on their intent to. It's not just, hey, we want all this stuff. It's no, I pay all you, my old job used to be there to pay lots of vendors lots of money to buy things. They're going to basically go to all those vendors and say, hey, how come you aren't at these things? And why aren't you meeting all these standards? At least that's what I'm hoping they're going to say. Yes. Okay. Well, this may be by USC, but actually I think it's AT&T that's planning to host the next one. It's more by the host gets to pick it as opposed to the just like RIT chose to host this one in LA. So what's next? Obviously, join this group. Okay, the planning for all this and everything else occurs in the cybersecurity automation sub-project. There's a mailing list, there's meetings. You can go to that site and meet it. Oh, look at this, it's always in the way. So there's never enough time. Thank you for yours. And now we have to do this one before we get kicked out. If I can figure out how to go backwards again. And like I said, we will make all the slides available. And I will maybe stop recording if I can find the button. Well, I'll stop recording the easy way. I'll get out of it.
Okay, thanks to everyone. We'll let you guys who are there in person clean up the room.
That's a solid plan.
Thanks. Bye.
Evening, everyone.